or after. So that way, you have what we call open invariant test and closed invariant test. So basically, what you are doing here is just attacking this condition. Okay, after this person, there's a certain based on my formula, there's a certain value that's expected to be in that's what I'm doing. So since I'm not able to actually go in depth into like the invariant test and I'm meant to cover the course for this. Like it's going to be you like see if the demonstration was good.
Yes.
So the sample that I played is like basically wrapped data. We all know that wrapped data is just basically how you go back like data moving. So I wrote invariant test basically just as different conditions. So let me just explain some it is so it is how we react to the so it means that the balance plus the W is supply that you have to always be equal to total usage supply you have. This is like an assertion that needs to always be every time like the transaction is going to be. But the reason is that if you have test for cases like this, it means that it's possible that you can train people on in the sense that I can now have a but because your does not have the needed amount, I not be able to like exchange, get the normal value that I'm supposed to get. So which is why it's needed that you actually test for conditions. So for invariant test, there are two concepts to just use. There's rules and there's tests. Causing allows you to like pass random inputs into a function to see how they behave on the system. But invariant testing, you can run those functions once and see how they behave with different values. So the test is how many times, the number of times you run this stuff. I know it does not really make sense. So I don't this does not really make sense at all. I guess I prepare for a more technical topic. Is there any question? No. For course, you are testing like a specific function and passing in random values. For invariant testing, you are testing the whole function based on some assumptions that we should. So like for example, one example where you can use like formulas like in terms of overflow and underflow, where you use like using that. So you can use those ones to see at which number your system. So that's like do you have any other question?
I know. But I think very much all, and they were like, well, developers and they already decided to speak. And when Danny was speaking, everyone was noting their head, they were clapping, and like, at the end of everything, I just said something. I said, I'm not supposed to understand what he said. So, and everyone was like, yeah, means. So that's what we just did. So I think yeah, also like this, I'm moving towards the city, so I'm going to be like talking about Foundry, Remix, like that. So like I'm very on mind. So we're going to talking about introduction to Foundry. How many of us have heard of Foundry before? Okay, so it might not be entirely new to the number of persons here. We can talk about introduction to Foundry. So all learn, don't get confused. If you are lost, just Google Maps.
So, foundries for content it's what we use to demonstrate like testing for invariants. And some of that is confused with like what invariant testing. The thing is like, why is it invariant? Like, what type of variant? Why is it variant? Like, it's changing, right? Like, it varies from one particular value to another, from one particular state to another. And when you actually try to test your circumstances, there are some things that are not supposed to change, actually. For example, if you have in a banking system, if the banking system has 20,000 applicants, customers, and each customer has a particular amount of money, then the total amount of customer funds the bank should actually be equals to the sum of all the balances of all the 20,000 customers. Right? If it should not be less than that, and it should not be greater than that. That it might be greater than that, so that will go for another metric. But when you're trying to like do like solvency reports, you're trying to make sure that the bank is not owing someone else some amount of money. Then you now assume that the total amount of money the bank should have is supposed to be equal to the total sum of the money that the customers have. That is an invariant. If that invariance fails, that means there's a problem somewhere, right? That means the bank has used someone's money to make it trade, or someone has made it to manipulate some funds and take some money out. Same applies to smart contracts, right? And like talk about ARC 2015, talk about lending and borrowing. There are some invariants and tools. For example, in an ARC 2015, the total amount of balances of all the tokens was because of the total supply of that thing. That's like a very, very simple invariant. And it can become more complex and more complex. So that's the like what I think was trying to say. I don't know, I think my case is like a physical work with the which is bad that's too fun. You guys have really seated around 2 p.m. Sorry, it was not 2 p.m. because of actually a lot of stuff for same circumstances. So that was just I don't know why. I would have just like this. Okay, so let me just start. Foundry is basically a tool you can use like interact with that develop smart contracts, deploy test, that's an example of testing to solve. And it is actually very fast because it was written in last year. One of the best languages. So this is what that guys, but I don't like it. So let's think. Let's just assume the root in another programming language. So it was written in like you guys, there was just rules, there was Sergio's, there was Matthias, and the other guys, and these guys are very, very loud. And I mean, before Foundry, there are like a lot of other development testing tools. There was Truffle, which was like what we used then in like, early days of Ethereum. That was in 2019, 2018. Truffle, everyone was Truffle. And then after Truffle came Highlight. And that was very, very nice because it allows you to like do custom scripting. And if you know how powerful custom scripting is, that means you can pull data from an external source and bring it to your smart contract directly. Makes things easier for you. For example, you can pull a large chunk of data from software and maybe do some magic on it, whatever you do, and just push it directly to your smart contract, all in one particular, say, workflow in this case. So, that actually allowed flexibility for developers, a lot of flexibility. People wrote scripts, people wrote tasks. Tasks are just like pre-written scripts. So if you write the task to meet a particular set of people, you don't need to like rewrite it, you just like run the task and provide maybe the address of one person needs to go to. So that like jobs in this case. And that was nice, but it was written in JavaScript. So JavaScript. That's JavaScript. I don't need to say more. So it was slow. I mean, compiling was a little bit slow. Wait for like 40 seconds to actually compile the whole code base one way or the other. Sorry, so that kind of issues that was like maybe trying to show you how it looks. So that was ADAT, and a lot of people still use ADAT today. And then Foundry. So Foundry was I think September 2021, if I'm not wrong. It should be September 2021. And then Foundry came out. Foundry was like, it wasn't written from scratch. There was actually a development tool called what was the name? DAP. It was called DAP. Something DAP. I can't remember. DAP tools. Thank you. Yeah. So that it was DAP tools, and DAP tools was actually written in Rust too, but it was not a general testing tool. It was written by like teams that actually wanted to have that functionality for their like organizations. Check it. So that means you as an outsider might not find it useful because the functions were more aligned with what that organization wanted. So that tool was like, and then someone was like, why don't we like that tool has a very nice infrastructure, right? Why don't we bring that tool and make it more general for everyone to use? And then Foundry. And Foundry is nice, it's super fast, it's super easy. The reason why it's easy is because Solidity developers do not need to branch to other languages to test their software, which was not the case in ADAT. If you wanted to use ADAT, you have to write your test in JavaScript or TypeScript, not to test your Solidity software, which was chaos. You know what it means when you shift like your brain to another like framework or like another language. As developers, you understand what I'm saying. It takes a little bit of the time to like adjust it first before you start writing the software. But if you're actually in that same language and you are testing your framework with that same language, and that's what Foundry does. You write your test in Solidity, you write your deployment in Solidity, and so on and so forth. And it actually gives you more closeness to say file system level support, like a lot of, you can do like any type of commands. You have system support like before. So if you want to do file system support, you have to start doing invite yourself, just because you have to also call OS now. OS call. You need to do something. And then you want to do JavaScript, like you need to do all these async covers and blah blah blah. But Foundry actually allows you to do that. Because of its closeness, like say system level. So this if you know now, I'm trying to like If like write a simple contract deploying on foundry test the foundry, it's supposed to be like a 100% practical session. I don't know why it's supposed to be. I mean, it shows that it's actually connected, but it's just like that. In this case, I'm trying everything, trying to duplicate situations or something. So this is the reason why in CTF we are going to be doing everything in Foundry. Greetings with Foundry. Whether the Foundry was tested in Foundry, which should be solved in Foundry. So that's the reason why let's like make it Foundry. CTF, we already showed you that exception yesterday. We know it has 500 books. And it should be faster. In fact, I told someone to help me guys trying to boilerplate. So that you do not have to set up everything from scratch. All you just have to do is like upload the recipe and start writing whatever code. Like as soon as we work for so I don't. So that's all about it. The next thing to go is of course practical now. Like just make writing report and what yes. I assume everybody here is looking from those. So if you are not, that's simple syntax. So what is lightning or what is very, very simple. So yeah, I assume that from down here. Sorry, if you are not familiar with anything, just confirm. It's because I know what today is. I know it's a battle between all of you and me only. It's like one big menu, one battle menu. And if you don't have something that have to do to fight, all that is point. You can install Foundry, it's very easy. If you go to the site, Foundry site, if you use Linux, it is easy. If you use Windows, please just go to one. Just back of that, so there's no point. It's not as if you can't install Foundry on Windows, but why? Why? So when you install, I'm not trying to delete those Windows. I mean, the use Windows for this computer software. But when it comes to making things work, like making things work, you have to come back to Linux. App Linux specifically. So if you are using Ubuntu, you are still doing Windows. I assume this might be all developers like to use that code. I assume it is a little bit seeable. Okay, so the light is necessary for the camera.
Let's symbolic test it. I'm coming. Okay. Oh, from the window, we can't stop nature in this case. So I assume, well, to some extent, okay, I'll try and increase the font. Let me see. I don't know how this laptop works. I think Control Plus should do it. Yes. So is it seeable? You can see like what you have there, right? Okay. So this is actually a sample directory. Like this is what it looks like when you have like an empty Foundry project. So to install Foundry, right? I think I should have access to his browser. Do I have access to your browser? Sorry. A lot of people use Brave. So let's just use Brave for this. Brave is okay. I think it's opened already. So just to install Foundry, the best thing to do is just search, right? Like install Foundry. So I typed something wrong. So install on Linux. That's it. We don't do Mac here. Sorry. I hate Mac. It's too what why? Mac, no. Mac is for people that want people to know they have money. Oh, sorry, let me just use Linux. I need to connect to a network. Okay, let me try it again. I said to be slow. Actually, just time. Wait. I think she's correct. Though. Okay, you know what? I'm not going to like just like installation guide for Foundry. Um why am I seeing this is not the Foundry I'm looking for. Let me just write, let me just put in like a keyword that would make it go to the original. All you need is just a keyword for Google. That's how the search engine works. So it's hosted on GitHub, and all you just have to do is you write Forge. So they have a script here. Um, let me get this. Okay, so I'll just make it very very big. So this is you running a simple Foundry test. This when you install Foundry using the script, which is on the repository, which I'm going to give you as like a boilerplate code, it comes with three pre-built binaries. So you can use Forge, you can use Anvil, and you can use Cast. So Forge is the guy that allows you to compile, that allows you to test, that allows you to deploy. That's Forge. There is Cast. Cast is the guy that allows you to make custom RPC calls. So if you want to do cast wallet. It has like a lot of. I've not used it personally. But, and finally, there is Anvil. Anvil is the same as your local node. E.g., I know a lot of you are familiar with Ganache, right? Ganache is like the first local node stuff. That app that was done with consensus by consensus, sorry, on consensus with consensus team in this case. But yeah, Forge is the guy you're looking for. So when you do things like Forge test, when you do things like Forge script, that means you are testing. That means you're running your script, or that means you're compiling, Forge compile or Forge build. There's no Forge compile actually. They call it build because they are build as it turns out to be. So let's just look at this guy. So you have lib, you have scripts. These guys are folders. You have test, you have SRC, you have git ignore. Everybody knows what git ignore is. Git modules. Git modules is actually something we don't like about Foundry because when you use ADAT, everybody is used to node modules, right? All you just have to do is if you want to use like contrast from OpenZeppelin or Uniswap, all you just need to do is find that their particular module name and you do npm install the module name, right? And you get all the contracts in your node modules. But in Foundry, we don't use node modules. We don't do that here. We use Git modules. And what Git modules literally does is like it creates a type of online symbolic link to that repository. So if OpenZeppelin contracts are hosted on OpenZeppelin's GitHub repository, right? And you use a Git module, what it will just do is link you to that repository instead. That's it. There is nothing like node modules. And that is why Foundry repos are very, very thin. Like they're always thin, unlike your front end people that you know yourself. And okay, so let me just tell you what this folders contain so that you won't be a little bit I think my time is up. So there's lib, right? And lib contains any of those libraries. So if you install the Open Zeppelin contract, you get Open Zeppelin. it will be there. Forge STD is a default library, and that is what gives you access to like all these nice testing functions and stuff. And finally, like the last stuff. And you have .github. Forget about that one. You have script. So what Foundry does when testing and what makes it very, very fast is that it doesn't make transactions when testing. It does make a cache memory. Deploys a test contract, right? Then makes like random, I won't use random because they're definite. So it makes like definite changes to state. So if you are testing, if you deploy a contract and you want to test if number X is equal to 1, it will deploy a contract, then use that contract to test the contract you just deployed. That is literally, it's a little bit hard, but it doesn't make transactions, right? On your local node, it doesn't. And that's what makes it fast. But scripts, when you have Foundry scripts, they will make transactions. For example, if you want to use Foundry to deploy a smart contract, that needs a transaction, right? You must be making changes to the blockchain. So all you just have to do is write a script. This is an example of a script, counter.s.so, and you can see it defines. It's like a normal Solidity contract, right? You have the Pragma Solidity version. You have import script console 2. Those ones are just for testing, and then you have contract counter script and function setup where you can do whatever you want to do in your setup, and then you have function run. Anything you have in your run function is what Foundry will execute on the blockchain. That's just it. Anything you have there. So in this place, you can see function run is doing vm.broadcast. When you say vm.broadcast, you are telling Foundry to actually broadcast that transaction to the blockchain. That is, you are making an on-chain transaction. I know they are ready. I'm almost done. Finally, okay, not that, second finally. We have SRC. SRC is where your contracts are. Like the contracts you write. The contracts you write this afternoon. That's where they should be. I don't know. If you don't write contracts, I don't know what you're going to do. But that's where they should be by default. SRC is where your contracts are. That is the contracts you are planning to deploy or anything. That is where they are. If you are planning to use contracts, I just give you an example. Then there's test. Of course, the name already says it all. All your test contracts should be here. And what your test contracts do is that they deploy your main contract, right? And they test against the state of that main contract. Don't worry, there's no time to actually delve into it and stuff. But this is just an example of a test, and it's very similar to your script. Just have you can see it is importing the contract it wants to test. The name of the contract itself is counter, but the name of the test contract counter test. So you can see it is importing it because it wants to test it. It needs that logic to test against that logic. It's normal stuff. And then you can see function setup. Setup is deploying the contract so that it can test it. You need to deploy it before you can interact with it. And finally, you have a sample test. Test increment, right? Test increment is just testing to see if X is going to increase. According to the contract, when you call the function set number and you pass in that number, it's supposed to increase on the blockchain. So that is what this guy is testing. Assert. Assert means I already talked about assert yesterday, so I don't need to talk about assert again. But assertion is just you are making sure it evaluates to true instead of false. And and lastly, the last one, if you want to run this test, what you just have to do is run Forge T. Forge T means Forge test. Some people will write TEST. Why? Just T. All right, Forge T, you are done. Some people want to finish it. Your terminal does not know you know English. It doesn't care. Just give me, there is an alias, right? And you can see it tests that particular function and tells you if it passes or fails. And if you want to like compile, although I assume most of you won't have time to compile, so you just be testing. Like this absolutely. So you do Forge B, which is Forge build. So and you that will just compile it. If it's telling you that I'm not going to compile because I've compiled, just force the guy. Like that means it will like get all the ABIs from the beginning, and you have something like this. So it's going to recompile it. F. Now you see, these are like should I wouldn't call them like you can call them extra arguments. Like when you have your normal argument or your normal command, you provide extra arguments. Those extra arguments cannot be shortened. You have to like dash force. Just like you use git now, git commit dash m. You do not say dash n because n is maybe lesser than m. You have to put M there. Okay. Sorry. I think that's all. Sorry, can I just 1 minute for questions? Just like you have like a funny question. Actually, funny questions only. Force. If yeah, force is a default command. It is not like a flag, right? Oh, git push dash F. But oh, just F. I'm sorry, I don't know how to use the git command line. I use the GUI. People that use the command line are wicked people. Personally, that's what I think. Just use the GUI, which is it's simple. Just click, and you're good to go. Instead of me knowing which branch to replace to which. What is that wahala? Just delete everything and try again. Okay, so yeah, thank you for. Oh, a question. Okay, final question. Okay.
Thank you. So I want to know the issue with Windows and Foundry. Yeah.
Let me tell you, Windows is not very friendly towards developers by default. Everyone knows, right? And even on Mac, if you want to install Foundry on Mac, you still get an issue. I think with what for those of you that use undownloaded Mac, I don't care. There's an issue with Mac. You need to install an extra library. There is.
There's no issue.
Documentation.
There's no issue.
So it's like, but yeah, Windows is not very friendly towards developers. So it's better to use Linux. Things like this work by default on Linux. Because on Windows, you're like, notes for Windows users. You have to do this, you have to do that, apparently, and everything. So I assume it's better to use Linux than Windows. Linux is not as crazy as you guys think. It has a graphical design interface. So why are you running from it? Don't run. But of course, you have to do command. So that's it. Yeah, that's the question.
Sorry, please, can you ask him afterwards? We're working with time. Sorry about that. He's available. He's outside. He's everywhere. You can ask him. Thank you very much. Please, let's give him a round of applause. Okay. So our next speaker is Griffin. And Griffin will be talking about understanding the Ethereum nodes. Please, let's give him a round of applause.
Hello. How are you? Oh, up here. So I've also had some technical difficulties, and I also don't have an HDMI cable, so I hope it's all right that I just talk. Yeah, or if the next speaker who's after me is like a presentation or something. Does anybody have a computer open up, like with a command line? Oh yeah, all right, maybe. Okay, no, I mean I can also talk a little bit. Sure. Um, yeah. Well, yeah.
So while we sort out the technicalities, we'll just go on to the next speaker. Is that fine? I want to.
I was gonna talk and yeah. Okay. Anyways, I can just do it. What? Well, so this can't actually connect to the HDMI. It doesn't have an HDMI port. Yeah. Yeah, I don't have a converter, and it won't actually connect. Yeah, it's fine. Okay, so can I ask how many people know anything, like have used the command line before? You guys, we got some command line people. How about, I guess you say Linux. I say Linux, but I think Linux, either one. Is anybody familiar with Linux? Linux? Okay, so everybody who's used Linux or even a Mac or a Unix-like system, you can run an Ethereum node if you want to. You can try. And this talk is about, so I brought a full node here. So that's an Ethereum full node. And I just kind of wanted to share a little bit about, what is it like to run a full node? What is a full node doing? Why should you run a full node? Why is it important? Yeah, has anybody run a full node before? You got one? Not yet? Yes, you have. Where did you run it? You just installed it and then started it. Yeah. So it's the reason I brought it here is because I feel like we imagine Ethereum and all this blockchain stuff to be like in the cloud, right? Somewhere out in the internet. But actually, you can run it on relatively cheap hardware. You can run it in your house. It might not be profitable. It definitely won't be profitable. So it's not a way to really make money, but it gives you this like connection to the network, and it's more like a hobby thing. You learn a lot about Linux. You learn a lot about setting up things like hard drives, and by running into these technical challenges like we have right now, you also learn to overcome the technical challenges, and you learn a little bit about how the whole system works, not just Ethereum, not just the blockchain, but also just Linux, hard drives, setting stuff up. So some of these technical difficulties I've had already, so I can't actually show you anything on the screen unless somebody wants to connect to. Well, I'd be interested to see if we can SSH into the. Do you have internet on there? We could try. Let's just try. Why not? This is supposed to be like informal. Okay, so while we're all right, we're gonna try this. It's probably not gonna work, so just to temper your expectations. But so a few misconceptions about running a full node. So do you need Ether in order to run a full node? No, you do not. You don't need anything. You need a computer to run a full node, but you don't need 32 Ether to run a full node. You need 32 Ether to stake and to be able to make money from running a full node. But you don't actually need 32 Ether to just run the node, because a full node is just collecting transactions, looking at the latest version of the chain, and then also proposing blocks. Oh no, it's not proposing blocks. It's just listening to transactions. It's following the chain, and it's helping to keep the network healthy. The staking part is an incentive, so you can make money if you have the 32 Ether, or if you have now a fraction, you can use a liquid staking service like Lido, but not necessarily. Okay, let's try. All right, so I've got this full node over here, and wait, hang on, let me find the IP address. Okay, so we're gonna do SSH. The username is Alice, so ALIC at 154.113.195.58, and then you're gonna do port number 2346. Maybe if you do just the IP address and then space and then dash port instead of the colon. So, oops, port verbosity. Maybe that'll work. Huh. Okay. Maybe it's not gonna work. So this is kind of the other big challenge. So let me just go over the different pieces for a full node. Okay. So first thing you need is a CPU. You need some kind of computer that's actually going to be running the software. It's listening to transactions, it's building those transactions into blocks, and it's connecting to other full nodes around the world. So here I have a Raspberry Pi that's running that software, and that's about like $100 US about. So it's not super expensive. It's not nothing, right? You still have to have the computer to do it, but it's a really cheap computer. It's like 8 GB of RAM. It's not so big. It's about, you know, this big. The second thing, does anybody else have any questions so far? No. So the second thing that's important is the space. You need a hard drive in order to run the full node. So the big misconception, what do you think is the most important feature of your hard drive? What do you need to run the blockchain? Yeah, storage. And a lot of people think that the limiting thing is the size of the storage space. You need like a big hard drive. But that's actually not the limiting feature of a full node. The limiting feature of the full node isn't how big your drive is, but how quickly your drive can write and read. So in order to get a full node running, and in order to have it keep up with the chain, you need to get one of these fast SSDs. So it needs to be able to read and write at a speed that can keep up with the Ethereum state. So I have this. So this is the, I don't know if you can see, it's a little bit hard. This is the hard drive that this full node is running. I guess, you think that's gonna work? I mean, yeah, this wasn't super well thought out about how to present on the full node when we can't connect to the presentation. Okay, so speed of your drive is important. So this drive is, I think it's like a Samsung SSD. So you cannot use a HDD. You can't use a drive that actually has a spinning disk. Too slow. The speed has to be about like 3,000 gigabit per second. I think that's the thing. So this drive, this is funny. We're showing you a video of just right here. I don't know if this is going to be that helpful. Maybe after the presentation, if you want to come check out what's going on. Is it working? Yeah, so this is the drive. It's about this big, fast memory. And then the other thing that's important, and this is one of those things that you learn if you actually try and like set up a full node, is it needs to be powered separately, at least if you have a crappy small computer like the Raspberry Pi. It doesn't have enough power to keep the drive running. So actually just before this presentation, the drive shut off for a second and created an error. And so then I had to run up to somebody who had a Linux computer and redo the drive setup. Oh, nice. Yeah, so this is the internet connection. Yeah, actually, could I show you, or could I go to a website real fast? All right, now let's explain a little bit about what's going on in the full node. Okay, so I am also not a developer and I'm not super technical. This is just kind of like my hobby. So I feel like we don't have to be that technical. Even the most basic things, I have to Google the commands every time to remember what the correct thing to do is. And that's fine. I think that this is, yeah. Oh, is this, you got, yeah. So this guy, Somar Isat, has the best explainers for how to set up a staking node, how to set up a full node. He's got all of the commands for what to do. And maybe we can do a, let's see, this is Lodestar, Ubuntu Nimbus, Ubuntu Prison. So I used Lighthouse. Yeah, so back in the day, there was just an Ethereum client. And actually way back in the day, in the early days of Ethereum, it was also a browser. There was this thing called Mist. and it was sort of like, it looked like Firefox or Chrome, and the vision was that it would be all one application. So you'd start up Mist, and it would run the blockchain in the background, and it would have a browser, and it would have your wallet, and it was all one thing. And then gradually that became not the vision. It was too complicated to have it all in one application. So now we have split into different things. Now we have MetaMask as a wallet. You use your normal browser, and then you connect to endpoints like Infura, or you run your own node. So it's important to remember the history of Ethereum. It used to be all one tight thing, and now it's all these separate things. So a full node is, harder. I feel like, where are we getting at? Huh? Yeah, this part. Aha, perfect. Okay, now we actually have a good visualization. Okay, so this is more or less what's going on in this full node. So instead of Ubuntu server, we have a Raspberry Pi. I think it's running Debian instead of Ubuntu. But now that we have, after the merge, we no longer get just one client. You have to run two clients simultaneously. You have to have one client that is called the consensus client, and that's what's doing, if you're staking, it's following something called the beacon chain, and that's what replaced proof of work in terms of consensus. So Lighthouse is our consensus client, and it's running a beacon chain node. So that's one service that's running on this Raspberry Pi right now. The second thing that you need is the execution client. Has anybody heard of Geth? Geth. Okay. So this Geth is the big one, but there are actually more than one different clients. And this is part of what makes Ethereum great, is that it's resilient against, where are we? Oh, I guess. I don't know. We'll just go back here. We'll just go back to this. Okay, so Geth is one execution client that you can use, but there's also Nethermind, there's also Nimbus, there's also, which one? Oh, Reth. Yeah, people have been talking about Reth. I've never, have you used it? Easy to set up? Maybe a little bit harder. I mean, but this is important, because if Geth has a bug or something and the network goes down, if 100% of all the nodes are using Geth, then the whole chain goes down. There have been moments in Ethereum's history where Geth has a bug and then goes down, but because there are multiple clients all doing the same thing, the chain stays running. So back in 2016, there were what's called the Shanghai attacks during DevCon 2 in Shanghai. Someone started attacking the chain. Geth died, but at the time there was Parity as a second client doing the same protocol, but doing it in a different way with a different backend. And so Parity kept the chain running. And this is part of the resilience of Ethereum, is that there's not just one client. You can choose to run Lighthouse. You can choose to run Prism. This is for Beacon node. You can choose to run Lighthouse, Prism, Teku, Nimbus, Aragon. Yeah, Aragon's a good one for archive nodes. And then for execution, there's Geth, there's Nethermind, there's Reth, and so on. So yeah, so you have to have a consensus and an execution. You have to have fast enough memory to keep the chain state going. And the last thing that you need is internet. You need a lot of internet. So if you're trying to run a full node in Nigeria, it could be difficult, but it could be possible. I don't know. The reason I brought this is actually also to test, to see whether it's possible using a normal internet connection to sync the chain. Right now, it's going to take like 6 days. Yeah, it's going to take a long time. it's going to be, yeah, so it's been running for about an hour and we're 1.05% synced through just the old chain headers. So this is going to need to run for about a week straight in order to pull down the whole chain. It's huge. And this is a problem, but it's the only way to get that decentralization. You have to be able to pull down the whole chain yourself to verify everything yourself, and only then can you be super sure that everything adds up, all the hashes link. It's part of the challenge of decentralization. But running a full node is important because it gives you connection to the network. You feel like you're doing something good for the community. And network topology is important because if you think about it, if you're connecting to Ethereum nodes that are all in Europe or in the US, this technology is not really that different from Web 2. It's the ability to run it here, to run it wherever you want, that creates that resilience. Yeah. I'm on the stage. Yeah. Where was I going? So creating this resilience is important, and running the nodes here help the network to, like, for example, I don't know, in places that I've been, if say just next door, if the military takes over the internet connections, that's censorship, right? And censorship resilience, censorship resistance comes from being able to stand this stuff up, to connect it, to run the node, to pass transactions, to do all the stuff that Ethereum does, and there's no permission required. Maybe there is a bit of a hardware investment required, so this whole setup is maybe like $300 worth. You don't need the screen, really. You don't need the super fast memory. You could probably get away with something a little bit cheaper, but like, it's not that big of an investment. It doesn't depend on these $1 million server farms. It doesn't need to sit in a big Microsoft building. You can run it at home. You can connect it to an internet connection. And that's what helps the network stay resilient, and helps everybody kind of participate on a level footing. Yeah, I wish we could have connected, but so I'll keep this running, and then all day we can talk about it if you have extra questions, or if you want to like mess around with the node, see how it's actually set up. Be happy to turn it off, turn it on, show you the logs. Yeah, it's more of a participation thing rather than a presentation thing. I'd rather do this off stage instead. Yeah, I don't know. Does anybody have any questions or anything? If you have really good internet, I don't think, again, I don't actually think the internet speed is super important. You do have to have a pretty fast connection, but it's the speed at which it can write and read from the drive. So no matter what, it's still gonna take like 24 hours at least. No, this is gonna take way longer. If you have a much faster computer and a fast connection and a fast drive, I think the best you can do is like 12 hours. It's still like, the drive size for an archive node, Aragon archive node, is like 600 gigabytes that you have to download. And that's a lot. And then, oh yeah, I didn't mention, so running the node uses about 1 terabyte, so 1,000 gigabytes per month. So you cannot do it if you're paying for data, paying per gigabyte. It's not worth it. You need to have an unlimited connection. So these are some, yeah, real challenges, because 1 terabyte per month is non-trivial. But this is one thing you realize, that's the cost of running a node. So when you're connecting through MetaMask to Infura, they're paying that for you. They're also collecting your data and getting money from staking and stuff. But it's possible to do that yourself. It just costs, you need to connect to the internet and pay for those costs. Yeah, any other questions? You had one?
All right. So with this machine, if I can be able to bring up the tweet here, I can actually become a verifier on the network. So what happens maybe if maybe I was assigned to verify a block, and maybe because of maybe network speed or data connection on my end, I wasn't able to verify the block. So will I actually be penalized fully, or will there be a kind of
Excellent question. Yeah, what are the fees associated? So if you are a validator, if you have 32 Ether, or maybe if you like cobble together with a bunch of people, do a liquid staking thing, yeah, what does validation look like? So it's a common misconception. It's not actually that stressful. So when you run a validator, let's just look at a random validator. Let's see, we can look at this block 12 minutes ago. Here's a block. It was proposed by this validator, validator number 584905. And you can see this is this validator's income level. So here's 23rd August, 25th August, and every epoch it's getting 0.002 Ether. So if this validator goes offline, at the same rate, it will lose 0.002 Ether. So this is, you don't actually like lose everything quickly. If your validator goes offline, if something happens, you can take it offline and you'll just lose a little bit. You lose what you would have gained. So if it's online, you gain a little bit every block, every second. And if it's offline, you lose a little bit every block, every second. The one time this is different is if you're going to propose a block. Then you don't lose, you just lose out on getting a lot. So maybe, I don't know if this validator has proposed a block. Blocks. Oh, so it's just got one block. Nice. This block. Cool, so this validator had a reward of 0.02 Ether. That's like $100, $200 at current prices or something like that. So if you're offline, you can't propose a block. So you don't lose money, you just lose out on getting the reward. So if your validator is offline and you're supposed to propose a block, you won't get that reward, and you want that reward. So those are the trade-offs, but you won't get slashed. Slashing is what happens when you propose a bad block or you're actually trying to cheat. Yeah. Any other questions?
So the speed of this stuff, is it relative to the location? Is it relative to the country you are? And if it is, why?
That is a great question. The speed. So what's the deal with the speed? So this technology, remember, it wasn't designed, there's no part of the design constraints to say, okay, we're going to have the nodes and it's going to be based in Europe and then this is part of the design, right? It's just in this abstract place called the internet. But where's the internet? I don't know. It's just in space. Not really. I mean, yeah, some of if we have Starlink, right, it goes to space and come down. But actually, most of the internet is in, if you think about it, in submarine cables. How am I on time? Am I taking too much time? 3 minutes? Okay. So if we look at the submarine cable map, so it's just peer-to-peer. So this is an interesting thing. if you imagine all of the Ethereum transactions that are coming from Nigeria, where do they go? They connect to the nearest Ethereum node, and then they get added to the chain. So if the nearest Ethereum node is also in Nigeria, then maybe all of the transactions will come from Nigeria. Network topology is weird, so the speed is dependent on everybody else connected to the network. So if you send a transaction and you're using an Infura node, and that Infura node has a server in Germany, then it's going to be slower because your transaction has to go through this cable all the way up to like Portugal and then get sent over fiber to wherever the server is that Infura is running. So it could potentially be faster if it stays in country. And also the rewards, if you have say a local block producer, then you have a greater chance of producing rewards if you're getting transactions first before other people get them. So the more people that would run nodes locally would actually make the transactions potentially faster locally. But it really depends on who's sending transactions, where they're sending transactions to, and where it connects. So this is kind of why right now Ethereum's could be considered a little bit, it's not fully decentralized, right? Because most of the nodes are going to be in places with faster internet. They're going to be listening to transactions. And if the transactions coming from France are really close to the node that's listening for transactions, then they're going to have a better chance of being included, whereas other nodes are listening from further away. So yeah, the speed totally depends, and it's healthier, it's better for the network if we have nodes that are closer to where the transactions are coming from. So it's really super important that transactions start coming, that we start getting nodes in other places in the world so that we actually have a global blockchain that is pulling transactions from everywhere, and more importantly, producing blocks and processing the transactions also everywhere, because that adds to the health of the network. Yeah, I think that's it. Yeah, all right. So I'll be around. I'm gonna try and sync the chain if they'll let me take up the internet. They might get mad for maybe it's slowing down the Wi-Fi, but here to answer questions after other presentations and stuff. But thanks for your time, everybody.
Thank you very much for that, Griffin. This was really, really educative and actually new. I've not attended a session like this before. So, Griffin, how can people reach you online if they have questions? Yeah.
Twitter or Telegram. So it's X. X. So I'm at GICHIBA. Anybody who I've already shared that with, feel free to share it with a GICHIBA. Yeah, that's my Twitter handle. Yeah.
Thank you very much. You can also check our Web3 Bridge Twitter account. He has also been tagged there, so you can just find him there. Is that fine? All right, so we're moving on to the next speaker for today, and his name is Adekunle Michael. Please let's give him a round of applause. And he'll be talking about from lag to lightning, harnessing the power of Redux multi-core for real-time dApps. All right, so while we wait for them to set up, so how's the session been for you guys so far? How? So many things to learn. Okay, but which parts are you interested? What about Foundry? Which one do you like the most? Which one do you think you explore when you get back home? The Foundry. Yeah. Oh, that's really, really good. Thank you.
Good morning, everyone. Oh, good afternoon, sorry. Actually, I'm angry at Timidan specifically because it was as if his talk was basically just to insult me, right? He talked about front-end developer, right? Yeah, he also talked about people who uses Git command line. And also about one thing I can't remember anymore. About Mac user, right? I'll get back at him, but may not be now. He's the only person that, okay, actually, two of them. Another person is also a smart contract developer that can just pick up their phone at 3 a.m. in the morning whenever they are having front-end issue. Just delete my number, please. Delete my number. Yeah, so this morning we'll be talking about how you can make your DApp faster and then get current data without having to do much on your front end. How many front end developers do you have here? Yeah, thank you. I'm speaking with, I can see my boss. He's speaking to us. So let's take a look. I will need someone. Abims, can you help me, please? And I say next. Yeah. So there's been when you're working with dApps, right? Well, one of the things you have to do regularly is fetching data from smart contracts, right? So once you just take is through where we've been and where we are currently. I don't know if you can see the screen clearly. So this, let's say initially now, when we started building dApps, so we want to get data. So this example is basically, I want to get users' investment in all the pools of Uniswap contracts, right? So this is what I'm doing. First of all, getting the length of the pair. Then for each of the index, I want to get the address. Then after which I'm getting the balances for each and return it. Next screen, please. So the problem here is that you notice a loop here. Two loops. So getting the addresses, I getting the balances. I think last time I checked, the total pair in factory, in Uniswap factory is about over 250,000. So you imagine how long this is going to take. In fact, I'm very sure most laptop will crash. Yeah, so what do we do to fix that? Next, please. Yeah, so we said, okay, let's try promise.all, our very old friend, very good friend. But next, also bad too. Very, very bad. Because you understand, there's a limit to how much call you can make. Every call consumes, should I say consume or uses memory? So this is going to be very bad for over 200,000 score. So we can't use this. Continue. Yeah, so the solution. So one of the things we're happy about in the early days was multi-core. Yeah. So we're able to reduce our calls down to just 2 calls, right? So this loop doesn't make any call, right? Basically just encode our functions call. Then this line, so this one and this one basically just make the aggregate. So first one to get the address, then the second one to get the balances, and we are done, right? So we submit our pull request, and we got a thumbs up. So all we basically did is convert our promise.all and our endless loop into this guy. Yeah, continue. Yeah, so it seems we're able to fix our problem, right? So why do we need Redux multi-core? So that is the question we are here to answer today. Are you guys following? Yeah. Continue. So it is great, right? But we still have some problems. Although those problems are not caused by multi-core themselves, most of them. I continue. So you notice that if I have to make aggregates, I have to first of all go through encode function signature, encode function call, forgot the function name, and then after I've gotten the data, I have to decode for each of them again. So these are things I have to kind of repeat for every call I want to make. So that's one of the problem. Next, then it is a one-off call. That is, it is kind of like a fire and forget call. So once I make the call, forget about it. So it doesn't matter whether the data on the blockchain has changed. It remains there until I make the call again before I get the current data. And then there's possible gas issue. So I lied to you guys earlier. The code I submitted might look like, the PR I submitted earlier might look like there was no problem, right? I'm sorry, there's a problem. Because we're basically just aggregating over 200,000 calls in one multi-core. You all know how multi-core works, right? You are calling a function through another function. through calling a number of function through another function. So and you all know there is like something called block gas limit. Although it's just a call, but because you are making the call through a contract, through a function call, then there's a limit placed on that. So there's no way you can fix that. If you want to fix it, it's going to be a lot of work here. Next. So, and that brings us to Redux multi-core. It's actually a tool by the Uniswap team. So they say it is a React Redux library for fetching, batching, and catching chain state via multi-core contract. Yeah, yeah. I know some of us don't like Redux, like the problems Redux brings, but there's a good news actually. Yeah. So, what does Redux multi-core do for us? Yeah, continue. So it took away an abstract repetitive code. So I mentioned earlier that they need to encode our function call, decode our results, and all the likes. So we're able to just take that out of our problem. Yeah, next. So it handles edge cases such as chunking to fix gas issue. So which was the major problem I said we had with the earlier code. So that one was going to fail. No doubt it's going to fail. So what the Redux multi-core does is basically gets your calls, then break them into chunks that I know would be successful for every call. So it breaks them down. Even if, let's say you want to make like 100 calls and notice that the 100 call might exceed the block gas limit, might just break it into two or three. So, yeah. Then it offers call deduplication. So what this does is, for example, now let's say you are working on a project, right? So we normally have this kind of user account components towards the header side, right? So let's say you are getting the user balance there, and again maybe you have a staking component where you're staking. You know, you do need to actually get the user balance there too. So you want to get the balance there, and then at the header, and then maybe elsewhere too. So what Redux multi-core does is that you totally makes one call for all these. So it uses something called keys. So it converts every call to keys. Before it makes any call, it checks the state. If there's a key that matches a particular call and return the results. That's all. Yeah. Then it's customized and automated data fetching and updating. This is one of my favorite features of Redux multi-core. So it works such that once you make a call, you don't have to worry about updating the call or updating the data, listening for change and the rest like that. Although there's a problem somewhere which we're going to discuss about. So that's what this does. So it automatically updates your UI. Yeah, next. So it supports multi-chain. So you can use it for multi-chain app, both concurrently or apps that require switching from one chain to another. Yeah. So let's dive a little deeper into Redux multi-core itself. So to work with Redux multi-core, so you need three components, right? You need the hub data, the hooks, and the reducer. So we are going to start from the reducer itself. So it is like a Redux like the Redux part of Redux multi-core. So you know we have Redux multi-core. So it is the Redux part of it. So what does it do for us? So in the reducer, we're able to save our global config. So there's a config you can just set globally for all your call. Yeah, so global config, the call listener, the results. So I made mention of call duplication earlier, where you are not making multiple calls for just one data. So there are listeners and their call issue. But the good news is that for reducer, you don't need to worry about setting up your reducer. It has been written already. You basically just need to add the reducer to your application root reducer. That's all. That's the only thing you have to do on that part. Next. That's all. Yeah. Yeah, so we are back to hooks now. So hooks are just like APIs through which we make our calls. So there are different hooks for different purposes. Yeah, next. Yeah, so this looks confusing, right? Lot of similar names that look similar and things like that. So we're talking about one of them one of them one after the other briefly. So use single core results. So this is basically just like the normal call you make with it. Like you want to get user balance, want to get token symbols, token name, and the rest. But this gets updated automatically whenever the data changes. That's all. Yeah. Then use single contract, multiple data. So this name kind of sounds intuitive. So format many calls to a function on a single contract with the function name and input specified. If you go back to the function, the multi-core function we wrote initially, while we were encoding our function call, so our function remain constant, which is all pairs, right? Then we're passing different IDs into it from 0 down to the last index. So we can use this for that, just a single call to make calling that functions with multiple inputs. So that's what this one does. Yeah. I'm not doing your work, sir. Yeah. So the next ones use multiple contracts, single data. So format the same calls to multiple similar contracts. Let's say you have like 100 or 1,000 ERC20 token contracts and you want to get user balance in all of them. So that's what this one does. So the same calls to multiple similar contracts. Next one. Use single contract with call data. So this is like the most flexible functions out of it. Although I haven't had any reason to use it. So you can actually call, you can literally call any number of functions on a single contract at the same time. So let's go back to Uniswap ERC20. So you can get the token name, the symbol, the decimal, allowance, balance, all in one call. Although you have to do a little bit of work, I said it offers flexibility, and with great power comes great responsibility, right? So you have to send in call data instead. For these ones, you basically just send in the contract interface, the function you want to call, and the input. But for this particular one, you have to manually decode your functions, like encode your function, like you pass in the target and then the call data. Yeah, next one. Yeah, so basically, most time, I've only used 3 of it, 3 of these, the first 3. I haven't used this, and the next we'll be talking about, I've never had to use because I've never had to build any concurrent multi-chain app together. Like, I mean, apps that runs both on Ethereum and main and BSC at the same time, not switching at the same time. So that's what you use it for. So you can use multi-chain, multi-core contract, single data. So it's same as this guy, use multiple contracts, but you can do it for different chain. Next one. So use multiple chain, single contract, single data. Basically, same thing as this first one, but for different chain. The next one. So the hub data. So the hub data is like the, should I say the engine or so? That is where the whole calls happens. So basically just check when it's time to call to get the data again according to your config. That's basically what that one does. Yeah, next. So with to use Visual Multicore, you need some dependencies. One which is the Uniswap version of Multicore 2 contract. So we all know Multicore 2 contract. We have Multicore 1, 2, and 3, right? So Multicore 2 contract is basically an improved version of Multicore 1 contract. So Uniswap team took that contract and basically strip off some unnecessary function and modify it for their use. And then like an update and hook to get block number as they have been produced, right? To get once a new block is produced, you get the block data. So that is what enables the updater to know when to fetch data again. Yeah. So this is just a basic pictorial representation of how Redux multi-core works. So from your components, you make a call, right? So the call gets converted to listener, and that listener goes into reducer, right? And then your hooks get your results from the reducer, that's Redux state, and send it back to your components. Your hub data takes listener from Redux and some config, fetch the data using the listener, returns the results into the reducer, into the Redux store, basically. So Redux is just basically like a central storage for your data, where hooks and listener, hooks and updater doesn't they don't communicate like at all. So they don't know about themselves. So it is the reducer that connects them together using the config, listener, and results. Yeah, next. So I have a very simple demo I prepared. So you can find it here. Jaimike/Wallet Explorer. So I want to basically just show you guys something. Can I go off the screen now? Yeah. Um, Jesus, my screen release. Yeah. So first thing first, let's just go to the app. So this is the app. Not sure. I don't know if you guys can see it. So basically, an explorer where you can just paste in any address, and it's. I use a lot of token lists. I think about 10 token lists I can find. So it is like several thousands of tokens. So I can paste in anybody's address and I'll be able to tell what token you can screw, what tokens they hold, right? So this was done with Redux Multicore. Yeah, so you can paste an address, you can change the network and the rest. So let's just dive into the code base. Don't worry. Yeah. So I want to just walk you guys through just a few minutes into the multicore itself. So I have a function here, multicore. Sorry, a folder, right? So is this legible? Uh, Zoom in again. Wow. All right. So basically like this. Okay. Let me just close this guy then. Yeah. So I have this guy. So this is the package unit swap slash reduce multicore, right? Uh, so you create a multicore instance. Then you can decide to leave this out, this reducer part, or add it. Doesn't change anything. I basically just pass in the default key, right? So from there, since I explained reducer first, let's just go to the reducer. So this guy gives us all the things we need. So gives us the hook, gives us the updaters, and then give us the hooks, reducer, and updaters, right? So we go to, first of all, have to go to our state, right? So I have a small state here. So this requires that you use Redux in your application. So I basically just add this to my Redux store. That's the only thing I have to do on the Redux part. So this application and list are just my custom states in the application. So and that is all for Redux Multicore in your states. So back to our, so I explained hook after that. So here is it. So you don't have to do this, right? This is the pattern Uniswap team took. So I decided to adopt the same. So if you notice all the function, there are two parameters that are constant. The first two parameters are constant, which is the chain ID and the latest block. So we basically just have a context that returns the chain ID and the last and the latest block, and basically re-export those functions in those hooks individually and passing in, skipping the first two parameter and automatically just passing in uh, our core context, which is the chain ID and the latest block. Actually, you don't have to do it. So basically, just re-export multi-core dot use single result, pass in the chain ID, latest block, and then the argument you passed in. Is this clear? You don't have to do this. If you're not doing this, basically for every call you make, you have to pass in chain ID and latest block. If you take a look at all the function call we're making, all the hooks, chain ID, latest block, that is part of what you have to pass into it. So because in this team sees that it is kind of like something you have to pass in for every call. Why not just save the user the stress of having to pass it? So that is why we have this particular file. So just basically skip first two parameters and then re-export it by passing in the first two parameters here. So the last one, which is the hop data, right? So the updater basically just, so these are the dependencies. You pass in the chain ID of the chain you want to basically make call to, the latest block number, the contract instance. So I said the user team can basically update the usability contract. So to better suit their need, right? So this is the instance of the contract. Then listener option. If you look at listener option is like basically the configurations you want for your calls, right? And the only options you have to pass is your blocks per fetch. Blocks per fetch is the number of blocks you have to wait in order to revalidate your data, in order to make another call again, right? So So if I check block per fetch, if you notice Arbitrum one, because I have about 4 networks here. So we have Ethereum, BSC, Polygon, Arbitrum, and Optimism. So for these 2 chains, because they are super fast, they are basically going to make our app misbehave if we are trying to get the data after every block. I think I don't know. I think 1 second or 2 seconds before another blocks are produced. So that's going to be a problem. So we're fetching the data after 15 blocks, which is just few seconds. Then Ethereum, which is slow, Ethereum, BSC are relatively slow, right? So we're getting the data after every new block. That is why we have one here. Yeah. So yeah, basically it's yeah. So let me just take a look at how we example of how to make a call, right? So let me just search use single contract. Mm. Okay, I'm basically just trying to get a basic example of how to use the hooks, right? Where's the page? Yeah, pages here. I know, I know, I know, I know. So use currency balance basically implements one of those hooks, right? So if I go into this guy, um, hmm, yeah, yeah. So use multiple data single contract, right? So I pass in the addresses. So these are the arrays of addresses I want to make calls to, right? So the contract interface and the function I want to call, right? Function I want to call and the input I'm passing. The inputs I'm passing for each of the inputs for each of those calls, right? Um, the gas requirement. This is not actually needed because there is like a default gas there. I think we're all confused here, right? So that is just it. If you have any question, we can just talk about this later. So let's just continue with this slide. Hmm? Yeah, so the final thoughts about this. So this basically helps us to forget about having to listen for events, having to worry about because it's actually not practical for this particular use case now. This application I bootstrapped, getting the user balance and then setting up events for each of those tokens, several thousands. That was going to be catastrophic, right? So Redux Mozilla was able to help us. But there's a very I don't know how serious it is, but I think it's something that needs to be fixed. So the problem here is that Redux Multicore basically, depending on your blocks per fetch, which it is reasonable to keep it at 1 block, except if the chain is let's say super fast, right? So for Ethereum now, right, we set the block per fetch to 1. So let's say I get basically let's say the name functions on it has 20, right? So I'll basically be getting that data every block. That name is not changing, right? So that's like making extra call, right? I don't know. Any of you might have may have that question. So that's basically making unnecessary calls to through your RPC. The problem will arise if let's say your RPC is rate limited or you are paying for calls per. You get the points, right? So that's one of the problems. So one thing I think can be done to improve that is basically maybe for every functions you are calling, you can just pass in a list of events that must be fired before the functions before the data are refreshed again. So that way you are sure that you're not just aimlessly fetching data again. So that is what I'm thinking of maybe can be added, right? I think that's all. If you have any question, I have just a few minutes. Yeah.
I want to know the Rados multi-core. Is it like a substitute, a brother to the graph protocol that we use to listen for events?
graph protocol is not the way graph protocol work is basically just index your contracts whenever the events are fired, gets the data and store it in the contract in the database. For some reason, I personally don't like graph. I don't like graph. I don't like graph because they are slow, right? You can't rely on them for real time something. Let's say, for example, something like balance now. Sometimes graph may be carrying stale data, so you can't rely on such. So you can't compare the graph to Redux Multicore. Redux Multicore basically just getting data directly from the smart contract, not from any database. Just so you know, graph fetches data from database, not from the blockchain. Yeah.
So looking at demo, I saw that it's updating real time. So I'm trying to understand the difference between this and WebSockets.
A WebSocket is basically PubSub. If you take a look, there's no time, but if you take a look at the updater, just go to Uniswap GitHub organization, search for Redux Multicore. Take a look at the updater. You notice what he was doing. So basically, for every new blocks, it checks, looks at the Redux state, checks for listener that are due to be called again, then make the call, store it in the state, and then the hooks. You know the way hooks works. Hooks always returns latest data, no matter where it's getting the data from. Always return latest data. So the hooks sees this change from the Redux state, then returns the new data to your component. Your component renders. Yeah.
Hi, I wanted to ask, what are the security considerations to think about when using the Redux Multicore? So I wanted to get your opinion on security considerations for using Redux Multicore to handle contracts, especially.
I can't think of any security issue with this because one, you're not making any any transaction on the contract on any contract. You're basically just getting data from the contract. So I don't know, but if you think of any, well, I don't think there's any security issue around this. You're basically just getting data you normally have gotten using your Ether, setting up contract instance and getting the data through the function call. Yeah. The logs. Yes. This is it. The only part Redux plays is basically just keeping your data, keeping your listener, keeping your results, and keeping your configs. So whenever user makes a new call, it goes as a listener into the reducer. Then the updater picks the listener up, fetch data, and then store the results back to the Redux state. And then your hooks notice the change, gets the data, and takes it to the component. That's all. Any more question? Instead of I personally haven't used WagMe before. I don't know. I think peer pressure haven't taken me to that place. So I don't know. But is WagMe always updating your data? Oh, in that case, that's good. But I can't compare that here because I don't know. Yeah. Yes, sir. Yes, sir. Okay. I get you. Let's say I have a function, right? That does some computation. So the function gets data from other contracts, does computation. You notice that there's a limit of amount of work you can do in a function. I don't know for smart contract developers. there's a limit to what you can have in a contract, in a function call. Am I lying? So the way multi-core works is you are making a call through multi-core, right? So I'm saying, okay, this function, I want you to help me get 1,000 results from these contracts. So basically that multi-core is making some computation on chain, right? Is that confusing? Yeah. So the multi-core the proxy contract I'm using is basically doing some computation on chain. Although it's not actually spending original gas, but there's actually a limit to amount of computation you can do in a function. So that is why we have this issue of block gas limit. Then the solution to this is basically chunking them into smaller calls that the function can handle. Is this clear? Any more question? All right. In the absence of more questions, yeah, thank you very much.
So hi everyone. So did you guys really understand what he was teaching? No, that was very honest. It's good. Who understood? Are you serious? Okay, who is into like front end Web3? Who does front end? Okay. Do you want to delve into the front end of Web3, the side, integration and all? Or do you do that currently? You do it. Is this something that you're struggling with right now, like stopping you from like fully mastering it or something? Yeah, you can actually. Sorry. Okay, sorry.
What do you say again? Come again. Okay. So my name is Emmanuel Nebeli. Yeah. So I'm a front-end web developer. Okay. So struggles. Well, for struggles, I would say I would prefer to just build the front end, make it responsive and fine, and leave the stress of interactivity to someone else. So that's struggles for me. But it doesn't mean I can't do it. But that's the struggles for me. Like sometimes it's stressful. You understand? Let me just do the front end, just do everything. The interactivity is to someone else. But I can do it myself, of course. Yeah, but it's stressful. But that's just it, sir.
You have some, you want to say something? Michael, I want to ask you something. Can you tell them like the importance of this? Or most of them, they don't understand why they need this. Yes.
Have you tried to listen to events before? I know this question I shouldn't be asking. As a front-end developer, I can't see hands. Like, so I think when you get it started, you notice how painful it can be. Sometimes maybe when you forget to clean up and a lot of things, you notice your events are getting fired multiple times. Sometimes your nodes are not giving you events when they are fired almost immediately, right? So you get to wait for some seconds and the rest. And again, the extra work of having to set up an event. And like I said earlier, it's impractical to set up events for what I just displayed here. Several thousands of tokens. It's impractical to set up an event. Plus, it's stressful to set up events. So the fact that you don't have to just make the call and you leave the rest to Redux multi-core to always give you the updated data at every point in time. Whenever anybody transfers your token, you know, okay, you are going to get the new balance. I think that is the fact that I don't have to basically worry about updating my front end anymore. I think that's a very big win.
So my question for you is that what resources we recommend for people to learn about this and also to get more deeply into the Web3 front end?
Unfortunately, I can't find any documentation online for this. I think that is why I chose this topic. I can't find any documentation. The only documentation you can see is just their repository. On their repository, there is actually an example or integration project, integration test project that you can just look into. If you look at the issue, I actually opened an issue at one certain point because I was having an issue with one of the configuration. Yeah, so there are no documentation, but you can reach out to me if you have any problem. And regarding front-end developers, Web3, more, I think just get your hands dirty. That's all. Get your hands dirty. Enough of watching tutorial video, enough of taking courses. Just watching and not doing it doesn't help. Just to get your hands dirty, like do something you're scared of. Just do it. If you have any problem, reach out to people and get it fixed.
Thank you very much. Can I give you a round of applause? So we're working with time, so you can actually reach out to him and he will connect you. Michael, please, can we reach out to you on Twitter? Is that fine? Okay, where do you want us to reach out to you? Telegram. Your name, sir? Sir Adek. Sir Adek, Adek, right? All right. So thank you very much. So moving on to our next speaker for today. Please, I would like to call upon on Idris. Idris will be talking about building full stack interchange app. Please, can you give me a round of applause?
better. I'm actually a computer engineer, hardware. Then also I'm moving into UI UX designing. That's product development. I actually need a community where I will be able to understand how to develop or design products that are marketable in the society and that can solve problems in the digital world.
Thank you very much. Do you want to move into like Web3 web UI UX in the Web3 space? All right, no problem then. So please, if you have resources, you can just reach out to him, or if you have a community that you know of, you can just inform him. This is how we grow. You have one more. Sorry, just one.
Okay. Once again, Emmanuel Nibili, front-end Web3 developer. Also a transitioning project manager. I'm big on freelancing. Yeah, so assistance. I'm looking to collaborate more with people, work on projects, solve people's problem.
Thank you very much. You know that you have a job now. So let's say it goes like, all right.
All right. Good afternoon, everyone. How are you all doing today? Okay, so this session is going to be a little bit technical, but I'll try my best to give you everything you need and also make you an expert building a cross-chain decentralized application, right? So you might be wondering what's cross-chain, how is cross-chain different from interchain, and all of those things. Those are the things we'll be talking about. And not just that, I prepared a repo with a step-to-step guide on how you can build a decentralized application that is not just deployed on a particular chain, but you can interact with it on different chain with a single click. Of course, providing SDK on-chain click, or probably if you're a JavaScript developer and you have interacted with SDKs multiple times, it's also going to be beneficial for you. So to start with, sorry, I just want to get to be sure I have the right audience. How many front-end developers do we have here? All right, cool. What about back-end developers? Yeah, back-end developers, those that don't like CSS. All right, so do we have full-stack developer here? All right, so I don't want to assume, but then, have anyone ever built or deployed any application on blockchain? Even if it's testnet, mainnet? All right, nice, cool. Okay, so today let's talk about building a full stack interchain app and how it is different from your application you deploy on a single chain. Is that you have SDKs to leverage for you to make those interactions happen. Next slide. Just screen, yeah. Okay, so a little bit about me. My name is Idris Olubisi. I am a software engineer and a technical writer. I currently work as a developer advocate at Axela, and you can find me everywhere on social media as OlaNetSoft. Next slide, please. Yeah, so these are the things we'll be covering in this session. We'll quickly go through how everything started in Web3, and then gradually move on to the Axela stack, how you can leverage the stack, or understanding the stack, what is happening under the hood, and also how you can leverage the stack to build a full stack interchain decentralized application, both front end and also the smart contract. Then send tokens, we'll talk about send tokens, we'll talk about general message passing, don't worry, all of these things, I'll explain what it means. And also, there'll be a very short demo if time permits. Next slide, please. So how did everything started? Between the era of 2019 to 2017, we have a lot of chains come up. We have the likes of Bitcoin, the likes of Compound, OX, Uniswap, and the rest. But then there was no way to interact, or there was no way to build application leveraging this blockchain technology itself. And then thanks to Ethereum going live during this era allowed developers to build smart contracts on the blockchain. So it means that you can customize anything of your choice and then still leverage the blockchain technology to build amazing decentralized application. But it didn't stop there. It's like we began to see a lot of issues around scalability, issues around how do I scale my application? Now I've built it, but then I need more features. I need more things. Then we see the likes of Polygon, the likes of Avalanche, layer 2 solution coming up to scale the issue we have in the blockchain space that has to do with scalability and many more. But then, new application requires more. It means that new protocol rather requires more decentralized application. Then we have this slide. Yes, so we everything started changing because people start to think about interoperability within the chain. Now, you have built your application on Ethereum. How can you extend that capability into like Avalanche, for example? Or let me say you built an application and it's supported by EVM ecosystem. So any EVM compatible chains, but then you want to, extend the capability of your application to Cosmos, for example. The Cosmos ecosystem is quite different from the EVM ecosystem, right? How can we bridge it? How can we make that interaction happen within the space? That's where we start to see things like the Aave. We start to see a lot more solutions thinking about interoperability within the space. But what is Axela going to do different, or how does Axela step into this omni chain or cross-chain era? Next slide. So if you're hearing Axela for the first time, it's a cross-chain interoperability protocol that allow you to interact within chain. So we have processed a lot. We've processed over 6 billion transactions on mainnet. We have over 45 chain integrated cross-chain. Like you can literally interact with all of these protocols with just single click. We have SDKs provided, but under the hood, I want you to understand that Axela itself is built on the Cosmos Tendermint SDK, right? It's also a protocol on its own with a lot of architecture behind it for interaction between different chains. Now we're talking about the EVM ecosystem, talking about the Cosmos ecosystem. How can we create interoperability within the EVM space? We have a lot of chains within the EVM space. How can we also make, extend that capability into other ecosystem like the Cosmos ecosystem? So all of this interaction being facilitated by Axela, but then there is also a thought about security, about user experience, developer experience. So we don't just want you to go through the hassle of building your own or trying to, figure out how to do all of these things from scratch. So we've provided SDKs that will allow you to just do all of this thing with a single click. So single click in this case is just a function call, and you'll be able to interact within those chains. Next slide. So let's quickly talk about the Axela stack. Slide. Yeah, so the Axela stack is shown right there, where we have the application layer. And this application layer, we have, you could have the EVM ecosystem. We have the Cosmos ecosystem. So all of these things, we have the Axela API layer that powers this interaction between this ecosystem. Right, so if you can see there, we have the gateway. So this gateway has smart contract deployed on each, for Ethereum to deploy, it's a smart contract deploy. And then you can see the interaction between the gateway to the cross-chain gateway protocol itself, which is the Axela network itself. So if there's any interaction coming from the application layer, it goes through the Axela API and directly to the gateway. And then before it gets routed to the destination chain, because ideally, if what you want to do, for example, you want to send a message from one protocol, that's the source chain. You're sending it to a particular destination chain. You don't know, probably you know the address of the destination chain, but then Axela takes this message after going through a consensus and then validators agree to verify that message, and then it gets routed to the destination chain. That's as simple as it is under the hood to understand how the Axela stack works. Next slide. So now we have tons of things, more than just sending token or bridging. But then let's start with sending tokens with Axela. Next slide. So under sending token, which I would like to refer it to as token superpowers, is we have 3 things that you could do there. Using deposit address, using send token, and also interchain token. Next slide. So the first one there is deposit address. Have you ever tried to, for example, you want to send a token programmatically from the front end, and you don't know, you want to make all of these things happen automatically, but then considering security and also making it happen on chain. That's where deposit address comes in. If you generate a deposit address, just like a single API call from the SDK, it takes in different parameters, like the source chain, where the token is currently on, and then the destination chain, where it is going to, and the deposit address, plus the asset that you want to send. Am I communicating? So now, this deposit address is generated automatically, and it means that if you give anybody that deposit address, just like an address that could receive fund, immediately anyone sends any particular token to that address, it gets routed to the destination chain without any manual interaction or intervention, right? So this is a very good use case. If you have ever seen any platform that deals with swapping, anyone heard about Squid? Squid. Okay, good. So Squid allow you to swap assets, and not just within a single ecosystem, but under the hood, they utilize Axela API to swap assets. So on the front end, what you just see is to enter the destination address, the asset you want to swap, the source chain, and then you click. So when you click, what you're doing under the hood is to generate the deposit address, and then when funds get sent to that deposit address generated, it gets redirected to the destination chain. So everything happened, putting into consideration a very good user experience, and also, of course, developer experience building that particular application allows any asset that gets sent to this deposit address to be routed to the destination chain without anything happening. Or maybe you don't need to trigger, or you don't need to call extra function to make that interaction happen. Next slide, please. So now, the second one here, I mentioned 3 under the send token superpowers. The second one here is, the first one is deposit address. The second one here is send token. This is a function that you can call on chain on your smart contract, and also takes parameter like destination chain, the address, the symbol, and then also the token that you want to send. So this is another way for you to leverage it. Now, the first one is with utilizing the Axela SDK. This is the second one that you can do directly on your smart contract, calling this function. Next slide. And then the final one here is the interchain token, right? So the interchain token basically allows you to send tokens cross-chain. This is another example of a way of moving token around, right? But then you also have the ability to do this cross-chain and then build your own asset bridge, leveraging this particular infrastructure provided by Axela. So how is this different from the ones I mentioned earlier? This one allows you to create your own token. For example, if you want to create a token on scratch, we have a portal where you could create the token and then select the chain that you want to deploy the token on, and then also select the remote chain token. So for example, you can deploy your token on Goli Ethereum, or like Ethereum, and then select a remote chain like Polygon, Avalanche, and then with this single click, all of those, your token will become available on all of this protocol. And the same way you interact with it on your source chain is the same way we interact with that token on all of this remote chain that you deploy it to. So it also gives you, you can upgrade the existing token. For example, if you already have your token on the network and you're thinking of making it cross-chain, you can just leverage the interchain token. It just simply allows you to leverage this functionality available for you to do cross-chain interactions. Next slide. So what I just mentioned, right? You can scan that QR code. That QR code is not part of the UI, but this is the UI for the interchain token service. For example, if you are not a developer, you don't want to go through coding before you can be able to deploy your own token. So going to this site, for example, here, I'm connected to the Polygon network. That's why you have seen Polygon logo here. But ideally, this depends on any network that you're connected to. So you can search for existing token if you have already deployed them, and then just continue with the process, make it an interchain, all on the user interface without doing anything like code or having to deploy anything. The platform deploys everything for you under the hood. Then you also have the option to deploy a new token, a new interchain token, right from the UI. If you already have your token on an existing platform and you want to make it available in other ecosystem, what you just need to do is to create and deploy a fresh token. Slide. So now, at the beginning of this talk, I mentioned about the Axela general message passing. What is it all about? Next slide. So we have two options here. So the first category I talked about is sending token, moving asset around, leveraging the Axela SDK from the front end, leveraging the functionality on your smart contract, or leveraging the interchain token portal that was created. But then we have the send messages superpowers, right? Like core contracts with token. These are like two categories that we have. So the first one, you can allow you to send message from one protocol to the other. And then the second one, allow you to send message, but not just message, but message and token from one protocol to the other. Next slide. So this is a typical example of how you can send, or what are the parameters that you could pass to send message from one protocol to the other. So we have the destination. You also pass, like, it's a function. You can call this function on chain. You pass the parameter, the destination chain, the contract address, and then the payload. So payload here is important to know that payload could be anything, right? If you want to pass a string, you can pass it. If you want to pass an array, any data type, basically, it will be encoded in the payload. And then the execute function here, you don't need to, like, this execute function gets run automatically on the destination chain by Axela. So what you just need to do is to specify, then it decodes what is happening on the payload, and then, move that message from your source chain, since this is running on the destination chain. So if you have anything, or, this is an internal virtual function that you could specify things you want to do on the destination chain. So this gets triggered on the source chain, and then this automatically happens on the destination chain. So the focus here is to add this into your code, specify any functionality that you want within the core contract, and also if you want anything to happen automatically on the destination chain, you can just specify it into this function, and it gets run automatically after deploying and then making that call from the source chain. Next slide. So this is the second one. It enables you to do the same thing with core contract, but then you can add a payload and also add assets. So you might be wondering, all of this, like sending messages, does it even make sense? Like, why do I need to do that? We've seen like different protocol. Anyone heard about Junkyard NFT? You've heard about it, good. So just for others, right? Junkyard NFT allow you to dump your worthless NFT. Anyone have an NFT yet? Do we all have an NFT? Or have you ever bought one that you bought it high price, then now it's worthless, right? So you can check it out. Junkyard NFT, what they do is you can dump your worthless NFT that's of no use anymore, or maybe the value has dropped to zero. When you dump it, they allow you to fish a valuable NFT. So what you are basically doing is dumping it on the Ethereum ecosystem. They have a contract deployed on Ethereum. And then if you want to fish like valuable NFTs, that interaction happens on Polygon. So now, under the hood, they are facilitating this interaction from Ethereum to Polygon, powered by Axela, to make this interaction happen with it, because typically you drop on Ethereum and then you fish on Polygon. But then they still understand the user that is dumping and also the user that is fishing. So all of these things happen on the platform. I'm just trying to explain what happens under the hood. But on the UI, you see, you can connect your wallet, dump your NFT, and then when it's time for you to fish, you fish a valuable NFT from the entire pool. So all of this interaction, all of this, sending things cross-chain happens. For that example, I gave a typical example of how people are using Axela to power interaction between different chains, between different ecosystems. It's like. So now, to the demo part, right? So if you want to follow along, right, you can just go to this website, the Full Stack Interchain dApp, that's bit.ly/Full Stack Interchain dApp. So it's very simple, right? We clone the project, we install dependencies, and also set up a wallet environment variable. So this wallet environment, these steps you are seeing here can be found on this particular project. So cloning this project on the README, you find a step-by-step what you need to do after you clone the project, how you can set up the environment variable, how you can set up the wallet environment, wallet environment variable, how you can compile and deploy the smart contract. So I'll show you how all of these things look like in a moment. And then how you can add the contract address to variable, how you can access the application on your browser. So one thing you need to understand is there's a lot when it comes to interoperability. For example, if you want to build your own from scratch, you can spend months, years to figure out infrastructure that can work with both EVM ecosystem and also Cosmos. That is why Axela exists, right? To think about, like, do the heavy lifting for you as a developer, but then provide a single function call for you to leverage. So you don't need to worry about things, how to set up from scratch, how to build the architecture entirely from scratch. You just need to focus more on your business model, focus more on the use case that or the problem you're trying to solve. So that is why we've provided the SDK. So let me quickly show what it looks like. Second. Okay. Can you see the screen? Oh, good. All right. So I mentioned like sending interaction or facilitating interaction between different chain. So the SDK that we provide is this, where you could typically just install it. You have the Axela network here. You can see the SDK here. You're leveraging the Axela executables, and so we have three things here we're getting from the Axela network. We have the Axela executable, we have the Axela gateway. I mentioned earlier that we have different gateway deployed on different protocol. And then we have in this case, we're using like the ERC20. So what are we doing here? We're typically creating a contract that allows users to send message from one protocol to the other, like any protocol. As of today, we have 45 plus protocol connected. So it means that you can have access to 45 protocol by just connecting with the Axela SDK, right directly from your smart contract. So what I'm doing here is I'm creating three variables here that holds the source of value. So value in this case is the message that we want to send. And then source chain, where the message is coming from, the source chain, the chain that it's coming from, and then the address of that chain. So next one, you can see I'm also creating a state variable, which is an immutable variable called the gas service. So I mentioned that we have Axela help you to facilitate interaction cross-chain. Fine. But how do you handle gas payments? Of course, you need to pay gas. But one good thing is that what Axela enables is to allow you to pay gas on your source chain with your source native token. So if you are on Polygon, for example, and you want to send message from Polygon to Avalanche, you pay in Polygon, right? And then the entire facilitation or the entire transaction is being paid. You can pay for it once. So you don't need to pay on the destination chain. Once you pay on the source chain, any source chain that you have, that payment is valuable for you through the entire transaction, both on the source chain and the destination chain. So which is why you're seeing gas service here from, of course, the gas service SDK that we imported here. And we created a source. So one thing, before you deploy a smart contract, a cross-chain or interchain smart contract, you need to specify the gateway, and also you need to specify the gas receiver. So the gas receiver has already been deployed. So if you go to, give me a second, let me show you where you can find. So if you go to the docs, the Axela docs, docs.axela.dev, you can find, scrolling down to the test net. Oh yeah, so on the test net, I don't know, is it okay? So on the testnet, for example, you see the Ethereum and then the BNB chain. So for every network that you have a gateway contract already deployed. So you can just come here and copy your gateway contract and also the gas service contract and then add it here when you want to deploy it, which is what this constructor is requesting for, the gateway and also the gas receiver. Then this is a single function that you can create to facilitate sending that particular interaction from one protocol to the other. So you can see the send message function that I created. So typically you can, after deploying this smart contract, you can interact with this smart contract from your front end with React.js. And then all you need to do is to just call this particular function, passing the destination chain, destination address, and the value. So the value here could be any string or anything that you want to send cross-chain. And then we are doing a quick check here to ensure that you have a gas paid and also you also pay for native gas. So when you want, after connecting your wallet, once you click pay, you get charged, you pay for the gas, and also that covers like the entire transaction from any protocol that you're sending this message from. Then finally, we call the call contract token, which I talked about during the presentation, where you can specify the destination chain, the address, and the payload. Payload here, just to reiterate again, payload here could be an array, a string, a JSON, or whatever that you want to encode. And then this is the final one I want you to understand is the underscore execute method that gets run automatically. Here you can see it takes the source chain, the source address, and also the payload. What is it doing here is decoding whatever value that was sent from the source chain. And then, if you want to do anything on the destination chain here, you can just do it right here. But what I'm specifically doing here is to pass in the source chain, just to know, to be sure where the message is coming from, and then pass in the source address, and that's it. So this is a very good example of a contract that allow you to send message from one protocol to the other. So you can send message with contract, a message alone, or you can send message with token. So you have two options. Here, in this example, we're leveraging sending messages only, right? But if you want to send message with token assets, you can just send message or call contract with token. So you can see right this line here, line 47, we are calling call contract. But if you want to send message and token, you call contract with token. So that's a very good example. But then you can find it on that project. After cloning the project, you see all the steps and also all the things that you need to know. Then back to the presentation, we have the Acceler examples. Another thing we've come to think of is that if you want to do, for example, I mentioned you leveraging the send token functionality, leveraging the deposit address. These are a lot of things that you need to, find here and there, going through the docs and all of those things. So we prepared this Acceler example repository where you find everything that you need with examples, right? We also value the developer experience. And we know a lot of people like to just copy and paste things to try things out first. So we've created this repository for you to try things on your own, and not just trying things out, but for you to see like the different things that you can do, leveraging the Acceler SDK. And not just on the contract side, we've also prepared a front-end Next.js application that you can easily, test things out. So if you go to this URL here, the Acceler examples, or just Google Acceler examples, to take you to this repository, you can find a lot of code samples or contracts that you can just quickly utilize. So what next? It is easy to build an interchain decentralized application leveraging the Acceler SDK or the protocol itself. And then we also provide full support should in case you have any error or any issues or you're trying to deploy anything. We have a dedicated channel, a forum on our Discord where you could ask. You always find me there, Idris. So you can ask any question. In fact, it might not even be question. It might be maybe you just need clarity or recommendation, or there are things that you are hoping to get as currently not available. You can just reach out to us. We'll be happy to help, and you can of course scan the code to join right away. Next slide. Whew, I think that's it. Thank you very much for having me.
Thank you very much for that, Idris. So if you have any question, you can connect with him at Idris at this is his Twitter name. So everyone should know him. He's a big man on Twitter, by the way, if you don't know.
You can scan the QR code to let me know how session helped you in any way. And it takes less than 1 minute for you to just fill in.
Thank you very much for that, Idris. Thank you so much. So I know that some of you are like confused on what's happening. But what I can say is that what will make you different from every other developer in the market is your knowledge and what you can do. You can't just be a regular front-end developer and be expecting to be any 5K. It's possible, but then it's not. It's very hard. You need years of experience, and then what exactly can you do to differentiate yourself? So if it's like you know how to interact with different chains, or you've deployed an app here, or you deployed on this blockchain and that one, all these little experiences help you. So my advice to you is that when you get to just go through the repo, go through different projects, and just play around with things. We are developers, so we just build them. Thank you. Thank you very much, Idris. Any question? Ugh. So, okay, just one question. Please, every other person will have to just meet him afterwards. Just one, please. One question only.
Good day, guys. Good day, Idris. So, my question is, spoke about Squid. So, how do you feel liquidity fractionalization could be solved with Axela?
So we understand how like the issues with fragmentation generally, and then so what we're basically doing is we enable developer to move application to where the assets are. So let me give you a typical example here. You have your application or your token deployed on Ethereum. So what we are basically doing for you at Axela is if you want to extend that capability to other protocols, we are only helping you to deploy those tokens. So we are not moving your assets. Your asset is not being fragmented. We are just like giving users the same ability they have on your source chain where you initially deploy the contract on, and then just extending it to other protocols. So your asset remains. We understand, we value and understand your liquidity, but we are just moving applications all around. So if you deploy on chain A, we give you access or enable that particular interactions that you have on chain A. We enable it on chain B, chain C, and you can interact with them the same way. We are not moving those assets away from where it is, and we are not fragmenting the liquidity in any way, because we understand the fragmentation issue, and also we prioritize security, we prioritize user experience, even though it doesn't seem like on the contract side, but on the front end, we want to give you something that once you call, you can easily tell, imagine, for example, Squid, if you want to swap any asset, it takes less than a second for you to swap asset from one protocol to the other. You can try it out. And this is happening because they leverage the Axela SDK, and they are enabled, they have a way of doing it very fast. So once you click on the front end, which is the user experience that we're talking about, you just click send or swap. It swaps it immediately, leveraging the SDK, because they're doing the same function call that I explained right now during the session. Hope that answers your question. Yeah, if it doesn't, but you can, of course, see me after the session. I'll be happy to help. Yeah.
Thank you. Please let's give me a round of applause. Okay, so for those that so there's match available. Who wants match? Still all of you. I didn't ask you cannot talk before. Look at you. So you can just meet him later and then we'll just talk about it, okay? Should I just give do give it away? Okay. Who wants? Thank you. I said something yesterday. I asked, what do you want? Just come out and take it. It's simple. Don't come out now. It's okay. Oh. All right, but don't worry. The match is going to be going around. Okay, let me just give it randomly. Randomly. I know what to throw. The place will be rowdy. Okay, I'm done. Just one. Ah! Wait, please. Wait. Oh, one, wait. I'll go. And the volunteer. All right. Sorry, let me give to her. She has been working. Thank you. All right, we're moving on to another session now. We're moving on to the remix. The remix for hackathon workshop. Please let's give a round of applause for David Disu. All right. So for those that are participating, the CTF is by 2. So get ready and we will start very soon. So if you need, just prepare yourself. We're starting very soon. So for those, just go and meet your teammates. How you just get ready. No. So how many people are participating in the CTF? Raise up your hand. So no one is doing the CTF. Wait. How many people are doing the CTF? Yeah. Just raise up your hand actually. Let us know. Wow. You really feel you guys want money. Wait, do you know how much is up for grabs? 1K, but in different levels, definitely. I didn't know that you guys are rich like this, so please, so who should I send my wallet address to? Just send me 1K. I don't mind. I don't mind actually. You want to give me 1K? Kelvin, you want to give me 1K? All right, I'm coming. I'll send it to you.
Um, Hi guys. David Disu from the Remix project at Ethereum Foundation. And I'm also here with my colleague, Joseph Izang from the Remix project also at the Ethereum Foundation. And yeah, I've got quite a bit of a presentation here. I actually have 110 slides. So are you guys ready? Yeah, we're gonna do it like it's gonna be fast learning. So we should please try to pay attention. Okay. Okay, so Remix for Hackathons is the title for this workshop, but then I wouldn't call it Remix for Hackathons. I would just say let's let's not take the title as it is and just look at it as we exploring Remix IDE and seeing new tools we can learn from. Okay, yeah, let's get started. Thank you. Okay, so what's Remix IDE? How many of us use Remix here or have had any interaction with Remix? Okay. Quite a number. Cool. That's nice. So that's half of the work done. So Remix is an online IDE that you can access from Ethereum, remix.ethereum.org. And it's a playground basically where you can create smart contracts using Solidity. There are also other languages. like Lexon, Cardio. It supports quite a few of them. And Remix also is good for prototyping. You want to test your applications quick, and then it's got everything set up for you. And we'll be looking at that. Here we go. Yeah. Okay, next. Yeah. So Remix is involved in, we use Remix in developing smart contracts. Like I said, we have the interface, we'll be getting there. These are like points, I guess we'll just be checking. Can you move on next? Also, because we have quite a lot to see, so we'll be fast. No, go back. Okay, yeah. So this is the layout of Remix ID. We have the side panel, the main panel, the icons panel. These are the three major parts of the IDE you'll be interacting with. We also have the terminal, is down below. Yeah, console, terminal, plugins manager, and all. But then the three major parts are the icons panel, main panel, and the side panel. Can you go next? So, no, you're too fast. On the plugin manager, there we have list of plugins. There are quite a lot of plugins you can use for smart contracts auditing, for deploying, for compiling. There are quite a lot. It's you just have to go through them, and then we also have the documentations for each plugin. If you want to get more information and be able to learn more about the use of a certain plugin. Okay, next. Yeah, so looking at the file explorer, we also have a bunch of options there. Now, a lot of people are not aware that you can actually right click and compile. Quite a number of people are used to maybe the Control S. I use the Control S while working on a smart contract. It just auto compiles the contract for me. But then there's the right click, you can flatten, you can generate UML diagrams and all. Can we go next? Aha, learning and learning fast. Yes, so, okay, yeah, so, can you go next? I was actually asked, we visited Web3 Bridge, I think 2 days ago, and then someone asked me if it's an advice I can give them. But then it just occurred to me that a good advice is being able to learn fast, It's something that it's very helpful as a developer, especially within the Web3 ecosystem. So learning fast. Learnet is a plugin which is good for learning fast, super fast. You can be able to go from zero knowledge, not the ZK proofs, but having completely zero knowledge to being an expert in using creating smart contracts and also using the IDE. Here we go. Thank you. Yeah, so these are a bunch of tutorials we have there, and we also have more. ERC20, ERC721. Yeah, they are all contracts. Quite a lot of nice stuffs are under Learnet, which you can use to self-learn. We'll move next. Yeah, so these icons are basically links that will link you to Learnet, so you can quickly, get started with Learnet. Next, thank you. And yeah, that's the Learnet plugin. That's how it looks like, and you can take each tutorial. Okay, next. What's that? No, okay. Solidity beginner course next. Thank you. Okay, that's also yeah, and also with the learner tutorial, you can be able to like answer questions, yeah, like Q&A session to be able to test your knowledge. So it's very helpful. It's very handy. Next. Okay, get into the docs next. Yeah. So like I mentioned, each plugin has its documentation, and you can easily find the link to the documentation by just hitting the top icon, and it will show you a little drop down where you can be able to access the documentation and be able to know more about it. Next. Start coding on an existing contract. Yep. Next. Workspaces. Remix also has workspaces. It wasn't there, I think, maybe a few maybe a few years ago. But then now we have workspaces with templates that you can customize, something similar to what Open Zeppelin has, the Open Zeppelin wizard. Yeah, next also. Yeah, so you can create a workspace, you select the options you want. Next. Yeah, next. Yeah, so that's the list of workspaces, and then you can customize it. Maybe have like make it mintable, burnable. I know. Next. Okay, yeah, good. So a lot of people are not aware of this, but then Remix ID also has the Git integrations with it. A lot of people just use Remix standalone without connecting their GitHub accounts to it. So you can actually connect your GitHub account. You can be able to clone repositories. You can commit, push. It's actually there, and you can even resolve match conflicts using Remix. The name of the plugin is Digit, and is also available. Next. Thank you. Yeah. So also you can be able to import a verified contract into Remix ID. You can do that by just editing the URL of that's on Etherscan. So say I want to get the whole source code of Uniswap, the Uniswap protocol. I just go to Etherscan. I look for the Uniswap contract, and then can you go next? I just change the URL from etherscan.io. I just put ethereum.remix.org / and it will import all the code that is deployed for that protocol. So you can also do that. I was hoping we'll be able to test out all of this in kind of like an interactive session, but I don't think that will be possible. So let's go on. Okay, yeah, this is an example of a contract that was imported into Scan. Next. Okay, yeah, Cookbook. How many of us have heard of Cookbook? Not really. Oh, okay. Yeah, there's someone that was behind. So Cookbook also have a plugin on Remix ID, and this plugin is really cool because it helps you learn fast. Because we're trying to learn fast. So it has in the plugin of Cookbook, there's Chef GPT. So it's basically like Chat GPT, but because it's a cookbook, it's Chef. So Chef GPT allows you to be able to get help while you're working on your smart contract. So once you have the smart contract open and you're struggling with a bug, you can just type, asking it questions about your contract, just being assistive, and it does that for you. So it's really cool, especially in this era we are now with AI and all. Next, yeah, yes, editing. Next, also. Yeah, okay. So you can also import codes outside Remix ID into Remix ID by using through GitHub, IPFS, gist, or just a HTTPS URL. It will also work. Next. Saving where did that file go? Oh, okay. Yes, so a lot of people have this challenge using Remix because they say it's a browser-based IDE, and they'll tell you the files just disappear. I think I had a few complaints of it crashing and then you losing files. So yeah, it's good to have it in the browser storage, but then just to be safe, you can always push it to your GitHub repo, or you can be able to download the files because we have the option to download a workspace. You can download it locally and save it. You can be able to use RemixD to maybe use it because RemixD is basically just a daemon that you connect to your application, your local file system to the online file system, and you're able to interact with the files. Next. Okay, yeah, RemixD next. Next, that's the way to connect to RemixD. You get this pop-up modal, and you just initialize your connections, and boom, it's working. Next. Okay, yeah. So RemixD also comes with Slither. Slither is is used a lot for analysis. I have 3 minutes. 3. Okay, so now I'm going to be super fast. Next. Okay, yeah, so you can be able to know if your workspace is connected to Git. There's just an icon there. Can you go to the next? You see the icon appear. Okay, good. That's the icon. And next. Yeah, okay, next. Okay, yeah. Next. We've talked about Git, right? Git operations. Next. Yeah, next. Okay, yeah. So go back. Good. We made some improvements to the editor, and we added quite a number of functionalities that helps with developing your smart contracts, like import statement. So immediately you have the import, it brings out options and different import options. And then we also made some improvements that it can be able to show you how much gas is being consumed by each function without even running your code. So once you just have it enabled, you see, okay, it's gonna cost this amount of GUI. And yeah, it's there. Okay, let's go. Next. Where are we? Next. Okay, yes. Good. Yeah. Also, we have the transaction recorder. A lot of people are not aware of transaction recorders, but you can actually record transactions and transactions that are being run from the run and deploy tab, so that in case you want to play them, so you have 10, 50 transactions, you can be able to replay it, and then it just automatically does that. It creates a scenario JS file, and you can use it for testing. It's very helpful. Next. Okay, back. Yeah, this is nice, cool. A lot of people are not aware, but you can be able to console log with Remix. So while developing, you can just add the console log, and then when you run when you run your contract, it just shows you the logs. Okay, what number are we on the slide? Oh, okay, 74. How is it still on the screen? Okay, just next till we get to the last page. Okay. Okay, so UML diagrams. No, just keep going. Yeah, yes, it's online. So yeah, people can have access to them. Yeah. Go. Okay, go back. Thank you. That's where I want to. I'm just sweating. Okay. Yeah, so the most of the parts that was skipped was about generating UML diagrams. They're really helpful for documentation, and also the path of its doc, and also verifying your code on Etherscan. We have an Etherscan plugin that allows you to be able to verify your deployed contract. It's really easy, it's seamless, and then once it's verified, you can be able to use the debugger. Also, the debugger is also a whole different tool that I'm sure we cannot be able to look at. Anyway, thank you for listening. I hope you're able to learn as fast as I was able to talk. Thank you.
The link to the slide. This is the last one. Wait. So this is the link to the slide. So I know everyone uses Remix. At least as a beginner, you start off with Remix. So you please just go through every single thing, so you can understand everything to full length. Okay? Are we good? All right, David, thank you very much. Can we clap for him? He actually tried for us. It's not easy. Any questions? We don't have time, but if you have questions, can you just meet him in the hall? I'm so sorry. You know your CTF is starting soon. That's why. Yes. Our next speaker, our final speaker before the CTF is Ademola Kelvin, and he will giving us like a hands-on practice with like Cairo syntax. Yesterday, the team spoke about like Stacknet and Cairo, but now you're just going to do like more of a practical session. So that's it. Also, wait. People that are leaving, wait. So we'll be done in like 15 minutes, and then Timmy Dan is just going to come up. So those people that are not after this session, if you are not participating in the CTF, you can go up to the main hall. And if you are participating, just stay here because of by 2 o'clock. Right now, everybody's just networking and talking, and there's nothing going on any other place. So by 2 o'clock, the contract will be deployed, and then the hacking can start. Starlink is available. You can connect. Yes, it is available. Oh, you can. Don't worry, you see it. It's just there. Yeah. So you can. The Wi-Fi is open. Anyone can connect for hacking and everything. But Tim Dan is coming very soon to just come and give you guys more information before we start. Are we okay? All right. All right.
Um, Good afternoon, everyone. Yeah, Ademola Kelvin, next slide, please. So, shortly we'll just get introduced to Cairo. I know how many of us were present at yesterday's session talking about Stacknet and stuff. So we have an idea of what Stacknet is as an ecosystem, right? Okay, this was supposed to be like an interactive session, but then I'll be fast with it. So just as you know that Stacknet enables you to write, is an L2, right, that helps scale Ethereum, right? So the architecture is somehow like different from Ethereum in the sense that there's an introduction of a new programming language, which is Cairo. How many of us are smart contract developers here? Okay, we know Solidity and stuff, right? So this talk is basically giving an overview of what Cairo is as a programming language and then its structure basically, and how you can like get started as a Cairo developer. So briefly, why Cairo? Cairo is a language for writing provable programs. What do I mean by provable programs? I don't know, maybe from yesterday you got to understand that when you want to like prove the validity of a transaction, right, on the Ethereum node, you need to sort of like re-execute those transactions. But then with Stacknet now, you have it such that you, with Cairo being a provable program, right, you can you can write programs, right, and then generates a proof for those programs. But then how does this sort of like occur? So that's what Cairo is basically. Cairo is a fostering complete language for writing provable programs. Okay. So to create provable programs and then a cryptographic proof generated alongside. Sorry, you can just meet me for like to know details about this. I'll go straight into the section directly. Oh, I want to try and zoom in. I want to zoom in. Hold on. Sorry, minutes, please. This slide is just to like show you what the previous syntax was like before and what it is currently. So now, just as you know that for every programming language, there are data types, right? Are we following this? Yeah. So, and we know that the data type we have in Solidity and stuff, like the Boolean, the signed and unsigned integers. But for Cairo, the data, so Cairo architecture is somehow like different from Solidity that we know, right? And everything you operate on in Cairo or Stacknet as an ecosystem is written in Felt, right? So we have Felt as the default data type. And then to enable the, the adoption of Cairo as a program, because writing programs in Felt is quite like difficult for developers, right? So there are sort of like abstraction to create new data types. So the new data types we have now, we have, can you please let me zoom in, please?
So you have felts, you have integers, you have boolean, you have short strings. So for now, Cairo doesn't really support long strings, support strings within the range of 31 characters. So, but there's always a workaround when working with strings, basically. So you have enums, you have structs, array, tuples. Next slide, please. Yeah, can you please zoom in? I don't know if this is clear. It's not. Okay. Sorry, let me just go to my repo. No. Ah, my internet is not connected. Please, sorry. I mean, please. So I just want to like show the codes for us, since the slide is not that clear. All right. Now, so let's take a dig at the architecture of Kairos. Of Cairo. So, sorry, I forgot to add. So, Cairo is a programming language on its own, right? And how does StackNet leverage on this? So, Cairo is not just limited at the contracts level, right? You can use Cairo on a normal day, like to write normal programs, such as computations of data structures or your normal day-to-day your normal day-to-day task. But then StackNet leverages on Cairo by creating plugins, right? So this enables you to like write StackNet contracts. So we have something, when you're writing pure Cairo, you're doing something called Cairo programs. But when you're writing StackNet contracts, when you're writing contract in StackNet, it's called like the program is called StackNet contract. So there's a difference between that. The difference is that when you're writing StackNet contract, you have access to the blockchain state, that is the StackNet state. But then when you're writing Cairo program, you don't have access to the state. So looking at the architecture, basically, right? You know that in Solidity, you have the first thing you define in your contract is you define pragma, solidity, then the what do you call it, the compiler version. So to define that this module is a contract, right, you have to like use the please can you scroll down a bit? Yeah, you have to use this attribute StackNet contract. And then what is this jargons we are seeing here? Just as you know in Solidity, when you want to write a contract, you have contracts, then the identifier, the name of your contract, right? So every contract in StackNet is a module. I don't have like, there's not enough time to get into like talking about modules and stuff now. So this is me basically specifying that I'm writing this. Okay, I want to like define a contract, right? And then this module is ERC20. So I want to like write an ERC20 contract. Now we know that. So this is me defining that this is a contract. Now, what are these import? These are basically imports. Now you know that in Solidity there are global variables exposed to you, the messages of sender, address these and stuff. So this is the mechanism in which it is being exposed in StackNet. You have use contract to get the contract caller, the messages of sender in this case. You can also get the address of that contract in particular. Please scroll down. So right. We come back to this. Can you please go to the contract? Go down, go down, go down. Yeah. So in Solidity, we write our state variables and things like that. But then how do we define state variables in Cairo? State variables are basically like defined using the attribute storage. And then with the struct storage, then you define the parameters you want to use as your state variables. Name, symbol, decimal, total supply, balance, allowance. these are basic things we are familiar with in Solidity, right? ERC20 token standard. We all know ERC20 token standard, right? Right. So this balance defines a mapping that maps a contract address, that maps an address type to a an unsigned uint 256 integer. So come down. Right. So basically, you know that I want to ask, like, what major actions can you like perform on the blockchain? Like, the generic actions you can perform on the blockchain. Write and read, right? Correct. So, Cairo, this our new Cairo new syntax is Rust inspired. I don't know if anyone writes Rust here. So you can see that it's somehow like Rust-like, right? And what Rust gives you is the capability to like manage memory using the borrow checker feature, right? So we have same thing here in Rust, such that you have to explicitly define when you want to like write to storage and when you want to like read from storage. And how do you do that? So as you can see, this constructor specifies ref, self, contract state, and then the parameters you're passing in. But then what does this mean? You're basically telling the program that you want to be able to like mutate this you want to be able to like mutate the state here. I don't know, like people that know Rust will like have like an idea about what this is, right? But basically, you're saying you want to like be able to like mutate the state. So now you can write, you can do self. So self in this case now references your storage. Can you please go on? References this state variable. So self.name.write, you're writing to storage, right? And then you have self. Sorry, please. Okay, self.symbol.write, self.decimal.write. So you're writing to the states now. So how do you read data to? So basically, to read data, you get a snapshot from your storage. That is where you specify this at keyword, right? So that's just like how you specify read and write. And this will be the question that what about function visibilities, external, view, pure, and the likes that we are familiar with in Solidity, right? Now, so the current syntax, you have to be explicit about specifying um, when your function is an external, when your function is external, basically. So you write external functions using the implement, using this implement, using implement keyword. Sorry, please, can you go up? This leads us to traits, basically, right? Yeah. Sorry, I have to like go to on interfaces. We know the concept of interfaces in Solidity, right? So to define interfaces, right? Interfaces enables like to enable like intercontract interaction and interaction with external contracts, right? But then how do we do that? Because here we are not dealing with object-oriented programming paradigm, right? So we are able to like define interfaces, and these interfaces, right? When you define an interface either in Rust or in Cairo, you have to like specify an implementation for it. You know, when you define interface in Solidity, it doesn't contain the full logic. It's just the function definition and then the parameters that it's expecting. So we are defining the interface name here, and then defining the interface IRC20, the function spec here, and the things we need. Can you come down, please? Now, to implement the trait, we basically use the implement keyword. Then we implement IRC20 of super IRC. So what the super is doing now is the interface is defined in the contract module, right? So to reference it, that's where the super keyword sort of like comes in. Now, we want to implement the functions we define in the trait. Then you define function name. You know we are dealing with reading from the contracts now. So the ref keyword will not be specified because you're not writing to the state, right? So you specify function name, then you want to get a snapshot from storage. Then what data type are you expecting? You're expecting a field 252. Then you do self.name.read, and things like that. So it's still basically the same. It's just a change of syntax. Please scroll down. Yeah. So how do we define events? Events are struct in Cairo. Just go up. Sorry. Up. Down a little bit. Yes. Okay. So for ERC20 contracts, you have transfer events, you have approval events, right? Now, to define an event, you use the keyword events. Then it has to implement the derived drop stacknet event state attribute basically. Then you define enum, the event you want. So events transfer, then has to take name transfer to. So basically, every event you need here has to be specified in this enum. And how do you implement the scroll down a little bit, please? No, to the event. Yeah. No. Okay. Yeah. So this is how you define your transfer events. You have a struct. Then, as you know, it's expecting the sender, a recipient, and an amount, right? Then you specify the sender, which is the contract address here, recipient, which is contract address, and then the amount that you are expecting. Then this is how you sort of like fill in the struct. So to now emit the events now, right? So you reference self.emit event, remember your enum, then the struct here, then you specify the transfer, then you pass in the parameters that is needed, right? So any questions so far? We are lost. No one is following. Any questions so far? Yeah.
Two questions that I have. The first question is, state variables in Cairo, are they like defined to within a struct? Because I observe that it looks like that's what you are doing here. And the second question is, are there like libraries, like OZ libraries for like Cairo and all?
Yeah, right. There are libraries. To start from that, there are libraries, but currently they are still work in progress, trying to like support the new syntax and how, not like support the new syntax basically, but have a migration of the former contracts to the latest syntax. Do you get? So there are there's support for libraries basically. And to the first question, looking at this state variables, they are defined as struct. That's how you define state variables. Look, you can't. Because if you do that, even your contract won't compile to tell you that you have to like define the state variables storage. So if you don't define it, if you don't have any state variable at all, just define storage struct, then the keyword storage, leave it empty. Do you get? I want to go back to the slide. Yeah, so basically this is just like playing around with logics and things and other things. So back to the slide. So I just like gave like a bit about the architecture. You have defined contract, then the global imports, defining state variables, and also other things like that. Yeah. So a little bit about when you define interfaces in Cairo. It sort of like generates a dispatcher for you. And what do we mean by dispatcher? Dispatcher generates two kinds of dispatcher. You have the library dispatcher and then you have the contract dispatcher. So this dispatcher enables you to make external calls to other contracts. Do you get? So what toolings do we use? So the idea of this workshop initially was to have like hands-on code along session, have you guys install StackNet Foundry. So you've had a session on Foundry, right? Yeah, so Foundry is a native tool for writing Solidity smart contracts, but in StackNet ecosystem too, we have StackNet Foundry, and then you have Scab for writing smart contracts. So other toolings you have are StackNet ADAT plugins, DevNet, StackNet React for your front end, and other all these ones. This was supposed to like be the whole session. Sure. Right. So just to kickstart your journey in Starknet, basically, we organize online boot camps, right? And then there's a session coming up September 6th by Stackware itself, right? It's Basecamp, just everything about Starknet, both at the front end level and also at like the smart contract level, and how you sort of like have your contract to contract to front end interaction. So you can scan this QR code, right, and then register, because the registration closes, I think, very soon. So if you're not interested in writing Starknet contracts, there are other ways you can like make contributions to the Starknet ecosystem. We have projects actively going on, such as you have Madara, Kakarot, Berus, like a lot of projects. So you might want to like check the list of, okay, these are communities, right? So if you join these communities, you'll see projects that are currently being built. And also in the Starknet Africa community, we have projects that we are building ourselves. So you can also like participate and help us contribute to that too. So these are a list of projects going on, and also ecosystem you can join. So your contributions would like mostly be appreciated using, like, you can contribute using Rust, Cairo, but if you're very, very, very good at Rust, you'll definitely like thrive in the ecosystem well. So to get started with Starknet contract, these are the resources you can use. You have a Cairo book that talks about Cairo as a language extensively, and then you have Starknet book that talks about how you utilize Cairo as a programming language to write Starknet contract. And then you have the Starknet doc, and this guy's article is David Barreto is the Starkware developer advocate, right? So he writes content on Cairo, Starknet. So to like have a dig about what the ecosystem is as entirely, you can like read his articles. They are beginner friendly. Next slide. Yeah, I think that is all. That is all. Do we have any question?
Right. You know that in normal solidity, I think event don't actually cause gas. Now in Cairo, since we are using struts for events, does it cause gas?
The question about gas, no would be my answer, because when you're consuming gas now, it's basically the let me use the word, the amount of logic that sort of like defines how much gas will be consumed. Take for instance, when you're dealing with arrays, right? And you have a function that writes to the storage and maybe writes to the storage basically, and then you're iterating on the array in storage. You know that it's going to like definitely cost you more. So it's not about the data type you use, but then more about like your amount of computations.
Thanks for the presentation. So say that I'm a Solidity developer, and maybe I don't know Rust, or Cairo seems it's a little bit more complicated, right? It's a little bit more difficult. I'm wondering, why is it worth investing? What can this do at a more like general level? Why is it worth learning about Cairo and about Starknet? What's the
To like, to answer that first thing, I think for developers as a whole, we like exploring new things, right? So I think that should like be the first motivation. Another thing is, from my own perspective, Cairo ecosystem, no, Starknet ecosystem is at a stage where Solidity was as far back as 2013-14, when Solidity was still like very, very young, right? So I know for a fact that Solidity had its own like learning curve, having updates being released continuously, and people couldn't like catch up. So learning about Cairo and Starknet contract, I think would like help you as a person, right? To get started in the Starknet ecosystem, because we are still like very, very at the early stage right now. And also it's a way to like equip yourself with new skills. And the community is awesome. Yeah. Any other question? And also, most importantly, like writing provable programs. Provable programs, yes. So, sorry, to learn more about like the Stacknet Africa community, you can meet with Emmanuel. He's our lead, the Stacknet Africa team lead. So meet with him, talk with him, and how you can join the community. Thanks.
Hi everyone. How you all feeling? Eh? You're tired. All right. Sorry about that. So it's time for what we have all been waiting for. It's CTF time. Yay! Hello, who's excited? Okay, for those people that don't know, CTF means capture the flag. It's basically a way of like contract hacking. So it's like you're trying to hack a smart contract, and that smart contract is actually money, there, dollars, and you get it. But this will help you build your dev skill. So it's actually starting now. So for those people that are not interested in doing this, you can please exit the hall and go upstairs and go and network with people upstairs or attend other sessions. But if you are interested, I would advise you to just like move forward and like form your teams or individual just stay. But you need your laptop to participate, by the way. You need a laptop, yes. And it's starting right now. So if you are not participating in it, you can just move. If you are, get your laptop out, get ready. Everything has been deployed so you can get started. So please, can we be quick about this? Thank you. Thank you. All right. Okay. Are you happy? That's nice. Are you happy? If you are hacking, please take a seat. If you are not hacking, please can you just step out for a moment? Thank you. Can you step out and go upstairs? The hackers in the house, please have your seats. We are starting very soon. Thank you.
Okay. You're not seeing the message. Are you sure you submitted your address yesterday? Have you all seen the repo? Go to Timidan. Yeah, search for Timidan on GitHub. Check your MetaMask, Abi, whatever wallet address. Your wallet address is wrong. Or so nobody has seen it. Nobody has received the 1.5 message. Timidan, the GitHub is GitHub. Timidan. GitHub. It's optional. Who has seen the contract? Accept it. We accept. I like the fact that everybody is still smiling. So that means our question, the question to me that set is very simple. How many hours? Yeah, I left. It was
No, that's yes. Sorry. Sorry, if you are not whitelisted, you won't be able to participate. I don't get it. Form, or you guys just address and your nickname. And I got conversation as I yesterday night, and I took note of those conversations. If you have not been whitelisted and you wish to be whitelisted, then just I don't know the like if you make transactions on the internet, sorry, to the blockchain, then Foundry will tell you the transaction is done, but you might not see it on Polygon scan because it is lagging. Even when I deployed it, that was why it took time for me to come. I just wanted to make sure the code was already deployed on the blockchain first before coming to you guys. So, but if you have not been whitelisted and you want to be whitelisted now, send your address. Same thing with the people that need Matic too. I'm looking for the best way to collect that info. I don't know the best way to collect. Sorry, I can't just pin up a Google form. So some people are boasting that they will finish this in 5 minutes. Uh, I mean, it's up to 10 minutes, and I've not seen any single transaction. So what happened? You thought it was solidity. So I'll try and spin up another Google form for you guys, where you can just submit your address, and I'll whitelist it. But you have to also submit a nickname in this case. We have 56 responses. That means I didn't whitelist them. What I'm going to do is I'm going to create a new fresh form and shorten the URL so that you guys can just go there and submit your address, and I'll whitelist you immediately so you can start. Um okay. I need Matic, so you can also use that address to submit your that form to submit your address, but don't add a um how would I put it? Don't add a nickname in this case. You can submit your address. I'm just sending you Matic. If I see your address without a nickname, then I assume you need Matic. Please note that you are ending 5 o'clock on the dot, like on the dot, no extensions. And if no, it can't actually. The money will still be there, but so if it stay there, I get the money. I've created a new. I don't want it to close down. I'm going to shorten the URL now. Sorry, I don't know if this. There are no transactions. Get this link out. Problems. I don't know why my PC is not like. So, like, I've created a new form for you guys that want to submit your address for either whitelisting or funding. It's online. Oh, I created a new link. Oh, can I? It's I shortened it. So let me just snap it. The people online have to be whitelisted before. Okay, no problem. Um, this is the link. After the like, I can't project my laptop. I don't know why. So I'll try. Let me see. Oh, sorry. Oh. Which one? On which one? Someone has tried the transaction. Someone has tried the transaction. So while you're hacking, I'll like continue to give like a little bit of um, small clues. Everything in that repository is a clue, right? Don't think it's just there for nothing. Everything there is a clue. So don't like overlook it. If you see X and you see X somewhere else, you should know they are interrelated one way or the other, like by chance, yeah, or something. So everything is a clue. The link for those who need Matage and for those who want to participate and have not been whitelisted. You still need Matage. The link, it's okay. They should have put it's online now. It should be online, but it's a shortened UI. Okay, they're still posting it online. It's a bit.ly link. So I'll just use like 5 letters. I can't project, so I'll just like tell you. I don't know it offhand now. It's on my phone. It's on my phone. Sorry. It's this. They'll be posting it online. After I get back my phone, I'll just tell you the link. Oh, wait. I actually have it on my PC. I have it here. There should be a bit that. Yes, there's one. This is for the first one. This is for the second contract. There's one transaction. The guy did not get it. So the link to like resubmit your details is bit.ly, like normal bit.ly. Okay. Sorry, can you collect my phone from me? Thank you. Bit.ly. Just of course there will be slash, then slash 3Z, capital letter Z, 25, capital letter X, small letter Z, and capital letter N. So okay? That's all, yeah. So just you said? Okay, so bit.ly, then slash 3 capital Z, 25, capital X, small Z, and capital letter N. 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 Any. Who said X? Did someone stop at X? Let me restart. Bit.ly, then slash 3 capital Z, then 25, capital X, small Z, and capital N. Not M, N. So I'll just check. If I get like 5 or 6 addresses, I'll do the transaction. If you want some match, drop your address, nothing else. If you want to participate, then drop your address and your nickname. That's all. That's not a question. How is it not beginner friendly? Sorry. I've seen a lot of transactions here. Transactions are coming in. Of course, they are succeeding, but money is not going out. What's going on? 5 minutes is equal. This you have spent approximately 20 minutes now. I'll calm down a little bit, and now you are stopping 3 o'clock. Remember, on the dot. Sorry, 5 o'clock on the dot. So I have 8 responses currently on the new form. 8, just 8. Okay, so I'll be whitelisting these 8 guys, and if there's still money, I'll be sending it to them. If there is still, in fact, no money safe, I'll just whitelist them. In this case.
I just want to mention that hope we all understand the architecture of the CTF we are playing. You know, there's an architecture which was displayed yesterday. There is an architecture, and also the README file is there for a purpose. Take your time and understand the README file. Maybe it will help a lot. So in order not to waste your time too much, you cannot solve level A, level B, level C, level D without opening the door. So don't focus on any of that. You cannot solve level A, level B, level C, level D without opening the door. They might have forgotten the architecture, because if you notice the architecture yesterday, the door was at the forefront, which lead you to either A or C. So you must solve you must solve the door before you go to either A or you go to either C. Then if you solve A, you can solve B. If you solve C, you can solve D. So there is like a hierarchy in the CTF. Yeah, you have a question. The GitHub, Timidan, my own, Falila, Falilah.
2 minutes. That's 120 minutes. That's 120 times 60 again. Seconds. I don't know what that is. I think I don't know, Sha, but it's many.
Say we should calm down. Let's take our time to understand the code. Let's understand it.
Who is the entrance? I gave this entrance in money yesterday. Why is this here? Who is the entrance? Someone's name is entrance.
Abibot has taken away the money. I want to see the polygon scan.
Oh, the polygon scan. I mean, it's interesting there somehow. Somehow interesting. I don't know where. At least for the first contract, we have. At least my money is still in the contract, and there's only one attempt, just one.
One attempt.
Second contract.
Just to mention, the second contract, no attempt.
Sorry, who is trying to solve the second contract?
Only few people.
Nobody.
Yes.
How's the point? Yes, don't verify. I don't see
Rockway. So, I want to, For whitelisting. Oh my, I don't want to whitelist your address again. Why is it not possible?
Don't whitelist it.
Yes.
Then send me your address. There's a form. That's bit.ly. Just go to bit.ly.
Oh, yeah. Okay, if since we are more than one, bit.ly slash 3 uppercase Z 25 uppercase X, then lowercase z and uppercase N. That's the link. Should I go again? bit.ly slash 3 capital letter Z 2 5 capital letter X, small letter Z and capital letter N. That is the link to submit your address for whitelisting.
an RPC error or something, that means your RPC is bad. Like your gateway to Polygon minutes. So I can't release my own RPC. No, you can't use it. So just go to chainlist.com and just go to Polygon minutes, and you'd see like a lot of RPCs to use for Polygon minutes. A lot actually, like a lot. So okay now. I assume it's going very well, actually. It is. I mean, I've seen 4 transactions. You will be able to interact. If you are not, you should get a revert error. Yes, there's a revert error. What's the error? Just normal reverts. No reverts. But that means your transaction went through. Let me check what transaction that is. One second. Can you tell me your address? Like the starting, like just this is F. Okay. 1 second. 0x, this is F. Okay, I see this guy. Yeah, I mean it works. That means you're whitelisted, but you are wrong. So yeah, sorry. You're whitelisted but wrong. Sorry, if you are whitelisted and you can interact and you make a wrong assumption, your transaction will go through. I'm not reverting for that. I want to waste your gas. So it will go through, but you won't get anything. That means you are wrong. So for the people trying, thanks for wasting your gas. I really appreciate that. Note that everything I put in that markdown document is a tip. Everything there. Nothing is extra information. Everything is a hint. So make your work easier, just look for hints. You're confused? Everything is there. Do not, like, one hint is that you should not forget about what the files are named when you find them. There is a very, very, should I say, small disparity between the file names and the variable names. One maps to the other. So if a file is named Y, try to find where Y is in the I've said too much. So for those guys, you have been whitelisted. You can now interact with the contract, but have not sent your 1.5 message yet. I will try and do so.
Since you said it's confused, I'm thinking we should just read the MD file together. Just normal. Maybe read it out as well. Okay. So I'll be using this place. So the first bullet there said magic number. And they give us description to it. Why did the computer believe in magic numbers? Because, like the question, why did the computer believe in magic numbers? Because they always seem to cast a spell on its calculation. TVH is just a random number. Then the second bullet, just a name. Web3 which founder has three names, but we like one better. Then the third bullet says secret missive. Luckily, this is easy. I mean, we provided it with the code. Um, X, a nice key to open the door. You find one of them lying around. All strings must be in lowercase. Please take note of that. And try to solve from bottom up. Yes, on-chain transactions are very good way to see important information. So that's for the door. Even if your let me just call it, even if your friend opens the door, you have to open your own door before you go ahead. Don't wait for somebody to open the door and think after the person has opened the door, you can go ahead. Everybody must open their own door before they move to the next level.
Oh, like secret underscore missive. Luckily, this is easy. I mean, we provided it with the code. We did. It's there now. Ah,
Maybe you should go and read your code. Abi, they said code there. You not receive any message. How do you know you've not been whitelisted? Okay, it's a view function I've been here. Our content is ready. Be done. Our money has reduced. The bad guy. Is the bad guy not here? Maybe so. Maybe you guys should try to check your wallet. You might not know you've solved this safe. Okay, you are ready to. You are ready to. Please help me. I can't remove it. Thank you. How do you identify yourself, Sha? But we'd like to know you. You said, is it? We don't know the person. You said Monette. Hey, our bad guys identified. Well done. Oh, yeah, go on to level A. Don't let him take all the money. Oh. We want more people to open the door. Okay, you guys are asking him to tell you. All of you cannot use the same thing to open the door. Monette. You don't like more money. Focus on your code. These guys are bad. We should remove them, Abby. Oh yeah, you guys, you are disturbing the whole of the CTF. What's going on? Ah, Mr. Monette, you don't like more money. Continue coding. If I were you, I will not answer anybody. Because you have higher chance than any other person in this contest now. You see that it is not hard. If somebody can solve it, definitely you can solve it too. I'm a motivational speaker. You can do it. Keep it up. We should separate them. Actually, there was no rule at the beginning of the contest. They said they can team up. But then, like, these guys, I know them very well. They their fault. I think I should separate you. Should I? Ah, Ayo, Uche, Kazim. You guys should separate yourself. Should we separate them? No. If you say no, so no problem. Money, it's paying me, Sha. It's paying me. Oh. That's so fast. It's not even up to 1 hour we started. I thought to me that no 1 hour. Well done, guys. You can see that it is possible. So thank God that somebody has been able to solve it. So you all know that it's something you can solve too.
Just call this link. Just call the link. Just call this link.
Okay. You can access this website for the front end. What's the front end? Okay. Fine. So you can just have this website open down. bit.ly slash 44x T capital letter B O capital letter U. Let me go again. Bit.ly 44x T capital letter B O capital letter U. So you can access the link for the front end so you can see what is going on the front end. I know we are all developers. You can decide to just use this one. So you can know how many hours you have left and how many hours you have left and any other thing, any other information you need might be there. So well done. Let's check the second contract, the unverified one. So nobody read bytes code here. Nobody read bytes code. Nobody. Senior developers. I really wish there is somebody. Maybe I can learn from that person. So, okay, this is Kelvin's system. Kelvin, come and plug your system, your charger, and let us open Polygon scan. The second CTF, how do we get? Second CTF, how are you fetching it? Okay. Yeah, somebody has unlocked the door. Okay, Moon next unlock the door. Okay. We can have 10,000 transactions on Polygon, but we can only see those that unlock the door successfully on our front end. So right now we only have one person, our bad guy, Munex. And which I thought we reached maximum address. Okay. This one sits here. Guys, what should we do to them? We should allow them. We should let them be. Okay. I said we should let you guys be. So what's going on, Kevin? Where's your charger? How to plug it that time? Why didn't you tell me? I didn't say what. No, I have to send it for. So, if you register for it, yes. Are you sure they did not verify you? Did not seem at all in your wallet. And you submitted yesterday. So if you need Martin, I'll have to print Martin. I can't change and unchanged function away. So, I've whitelisted you.
So for the new people I'm funding, get one. For the new addresses I'm funding, you get just one matic instead of 1.5. You have got sorry, give me your address for matic, Abeg. Your address. No, I just need like can you tell me the address? I have like what it starts with. 0x B. I'll find it, don't worry. I'll find it. It's me. OXBE. Oh, BB, right? Yeah, BB3, A1. What about okay? I'll send it now. Yours too. Okay, okay. I'll send yours now. What about you? You don't need. Oh, okay, 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 okay. Sorry. Just put like system screen time out to maybe 30 minutes or something. Yeah, sent. Sent? You since when? Wait. How did it disappear? You send the function with maximum gas value, and now you have used one matrix. You have used 1.5 matrix to send three transactions. But you got matrix before. How did it not disappear? Any outgoing transaction? That's not possible then. You know now. We are both developers now. Polygon scan might have an issue. Try to run a transaction. Polygon scan might have an issue.
Check your mental math.
So how's it going? You're almost done, okay. How's it going? You don't know steganography, have you? How's it going? It's going fine. You said? He's not whitelisted. How? Why? Did you submit your address? When? Today. It's hard for me to whitelist because the function is an array function, for Christ's sake. Yeah? What are the levels for? I've been explaining what the levels are for since yesterday. Remember, always check on-chain transactions. Those are like the most important ways to get data, fast data. For example, now, MoonX solved the door, right? Look at what MoonX did and do the same. It will work. Abi? You can open different doors with the same key. The gas fee is high. And hi, God. Oh, I'm supposed to actually whitelist someone. This laptop has suffered today. So, till 7 minutes more. 1 hour 37 minutes. And I might drop some hints in this way. So an hint about the door is that the name we are talking about is a Yoruba name. That's all. It's a Yoruba name. So if you have any names that are like English names, just remove it. But the name is a Yoruba name. It's like the best hint I can give you. So the link is bit.ly/3z, capital letter Z, like capital Z, then 25 capital X, then small letter Z, then capital N. N. N for Nutrimic. Bit.ly/3 capital letter Z, then 25, 3 capital letter Z, 25 capital letter X, then small letter Z, then capital letter N. Yeah, so that's the shortened link. I should have used the QR code, but my PC is not easy. You have gotten it right? It takes you to the form. Not found. 3Z 3Z25 .ly 3 capital letter Z slash 3Z. You have hash capital letter Z 25 capital letter X capital letter X small letter Z then capital letter N. Yeah. So there you go. So sorry if you have submitted to the new form, just tell me. 3. So I'm expecting 3 new addresses. I'm tired. How come only Moon X and even the Moon X self? What happened to level A? There's still level A and level B. There's still level C and level D. And let me see if there have been any transaction on the second contract. No transaction at all. In case you want to know, the second contract holds 540 matic, which is approximately $300. So that's even more than the first contract. So why is everybody focused on the first contract? You should do the second one. No multi levels, just one level and you get your money. I'll do it now.
Are using Foundry. They want to know the Foundry bosses in the house. Nobody is using Foundry. Maybe that's why you guys are taking time. Finish what? How many hours have you spent? James, this your face is not. Why you used to smile at? Looking at me like a wicked person. Am I timid? I'm not timid now. So who told you that? No, the poor will breathe surely now. The CTF is for all levels, like we all said. You can't deploy a remix. We don't. We should try add that of. Oh, fun. I did not teach you add that. Our curriculum did not get to add that. Yes, sir. Okay, you want me to tell you the architecture, Abby, again? You you need to break A before you break B. And you need to break C before you break D. But you don't need to break B before you break C. And you don't need to break either A or B before you break D. Like A and B are in different parts. Yeah. And C and D, they're in other parts. So you can focus on C. If you can start from C or you start from A. So today. But why can't you deploy a remix? You should be able to deploy a remix now. Oh, another bad guy. But you've opened the door. You can go ahead and he's still trying to solve the next level. Rich kids, what happened? Has gone off again. Yes. Who is Joseph Dara? Ah, bad guy. Now there's competition. On this side. Eh? You won't get money again now. It's only the first person that solved the question that will get the first money. So there's no money in that level again, but you cannot go forward until you solve that level.
I don't know why you guys are not attempting. I'm running the script now. You're not attempting the second contract.
People are attempting. We have bad guys there. They are attempting it.
It's because I've not seen like any transaction. That's why I'm asking.
They are still going to the level. It's a process, Abby. One step at a time. They will get there.
You can use anything you want. Trust me. You don't need to. You can interact with the contract anyhow.
Anyhow.
It's your choice. You're there.
Yes. The boiler template.
The first contract code, it's there, it's verified on Polygon Stack. I put the link in the MD now. The link of the set of the first smart contract is in the MD. And it is verified. So for those guys that are open the door, I also get either level A or level B.
Or level C to level D. Level D. What's the issue? He said, yeah, he's asking for high gas price. Why? Maybe you should check your. It's not supposed to cost you up to that amount. I don't know. Maybe your code is. I don't know what you have in your bytecode, Sha. So it's possible. I can't. I can't decide that. But we don't expect that. Who is opening our door again? Please stay calm. No tension. No tension at all. Why this state? How are you saying this thing?
So yeah, you're whitelisted for the last 4 guys.
And that's the last white list we are doing for the CTF. You got Matic before.
I don't know why you guys did so much address.
And you were in the hall yesterday. People should not waste our Matic. It's money. What Matic is you. 048. That's what it is. Our contract 2 guys. How is it going? Well done. It's interesting, right? Who next? and win our money. Come and win our money. Join us. Join us now. Play the CTF. How are you? Good afternoon.
We need someone to tell their Web3 bridge story. I can't find that page.
Okay.
So I need you. Thank you.
My baby is doing. I'm doing something. Okay, so I'm coming. Ah.
That's the point. Another hint is that you cannot reverse cryptographic hashes. You cannot have an hash and try to reverse it, but you can brute force. So that's what you should do for the door. You should brute force it. And the values you are supposed to brute force against are already on chain. So you just pick one, or even pick all the values and start brute forcing with random data and look for the one that equals what you are looking for. Until you get that, you are good to go. That's how you solve the door. Or that's how you open the door in this case. So you're not printing it now. You're not printing it.
You have to.
You're not putting it online.
You will. It's not fair.
As since yesterday, every day.
So, this will be the vex. So, where my phone? These scenes are picture worthy. Where you see a lot of people trying to collect the money that is not theirs. No, the cap is fine. I know some people start using ChatGPT. You copy something there, put it on ChatGPT. ChatGPT just tell you, I don't know what you're talking about. I need to take some pictures. Everybody's hacking here. Is that? You have lost it. Why? How did you tell me? I can't drop any into. Yeah, I've sent it now. 1.5. I've sent it. Wow. So fast. That was fast. I've not snapped this column. Don't worry, I'll cut you. I'll cut you from the picture. That's if you don't want to be in the picture, I'll cut you from the picture. All right. Um so this is 3:46. You have 1 hour, 14 minutes more. Sorry, oh yeah, 14 minutes. So another hint about the door. Let me first confirm the hint before I actually like tell you the hint. So you saw a lot of people opening the door with a particular key. One key, which is either 4 words or 5 words. Sorry, 4 letters or 5 letters. The key actually lies in the crossword puzzle. All you need to do is find a key that someone hasn't used, and maybe you can do the rest. It's simple. I mean, you can inspect all the transactions of the people that have solved it and look for what they did, apart from the key. The crossword puzzle is very simple. You just have to look left, right, up, down, diagonally, and you're good to go. That's like the best hint. Everybody should start solving door now. Like everybody should start solving door now. Everybody. I should start seeing your names. Open the door, 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 open the door. No need for. If you want to do contract, in fact, let me check the second contract. The second contract is very simple. Everything you need to solve the second contract relies on the story in challenge2.md. Everything is there. What I'll say about the second contract is that everything is a hash function or a cipher. So just try to map any bolded characters to a type of cipher, and you are good to go. What is the what? I don't know. I can't see anybody unlocking the door again. And And the people that unlock the door, what happened to level way? There's still more money to be won now. You guys have only taken like $100. The remaining 900 is coming to me. I hope you know. If you see me cruising tomorrow, nobody should ask many questions. That was the agreement between me and Web3 Bridge. They will say they will fund it, and if nobody can collect the money, it comes back to me. That's it. I don't care. Yeah, you can see the people that solved the door. Yeah. The transactions they use, they have something in common, which is the magic number. They both use the same magic number, one way or the other. But I don't know if that will be of help. Reading the second challenge out, we have challenge 2.md. It's like a story, but it's very like simple story. A lot of people have been able to decode the first binary that we have there. It's very simple. Like that's called binary exploitation in cybersecurity. Although even though what he just did was convert it from one form to another. And that binary file should take you somewhere where you get the other details. Very simple details. I have no idea what you are talking about in this point. Some people are getting pastebin.com slash xxxxx. One way or the other. There's still more info about the other, like hidden data there. Should be here. If you solve it, this dashboard will actually like update. I don't need to refresh. It does tries to fetch past logs over like a type of time bracket. So if you solved it, then it should automatically update. Your address is OXA7. Your address is OXA7 or is 9F. I don't see any transaction from 9F on the contract. Or are you talking about the second contract? I don't see. I'm checking Polygon scan now. Oh, OX9FC2. Yeah, you're wrong. You didn't emit the second event, so you're wrong. You're wrong. Like the transaction did not emit a second event. If you get it right, it will emit a second event. So that means you're wrong. What you guys are missing is when you get a character that looks unfamiliar, it means it is encoded. That's just it. All you just need to do is find what it was encoded with. After you find it, decode it, and you get whatever you are looking for. For example, when you are opening the door, you find a character that is very weird, but there is a text attached to it. It was like 32 bases or something. I mean, there's something called base 32. I've given you the answer for that, so the rest is on you. Oh yeah, I've literally given you the answer to unlock the door. What's going on? We have a lot of bases. There's base 64, there's base 32, there's base 91, there's base 16. And they are all encoding techniques that used to encode UTF-8 text to give you one random funny looking text. That one of those funny looking texts is what you see on the MD. And all you just have to do is decode it. That's it. Yeah, I'm looking for the people that were bragging yesterday. I don't see them. Some of them have given up. I've gone home. So you have 1 hour, 5 minutes left. An hour is a lot of time to actually break it. Even though I've given you the answer to the door. I don't want anybody to be stuck. The people that unlock the door first got the money. So the remaining of you guys shouldn't be stuck, right? So you can focus on the remaining 4 levels and maybe the second contract. It's funny that nobody is attempting the second contract. It doesn't make any sense. Why? Why is nobody attempting the second contract? It's like the simplest. And it has $300 for Christ's sake. Everybody's trying to solve the one that does not ever have money again. You know, if you solve the door, you don't get anything. You need to be the first person to solve that level to get the money out. That's weird. Yeah. So, sorry, how many people have given up? I just need a count. You have given up. Some people are spectators. They want to say we win and no won't. Okay, nobody. You have given up. Okay. What do you need? You need massage. Sorry. This write-up is very, very nice. It's very easy to convert binary to readable. I don't know. What do you think? Does it look like a link that you can append to the end of a paste bin? Yeah, you don't know until you try. You usually have the pasteme.com/xxs there. Why are you going to another stuff? I'll try and give you hints a little. For those of you that are showing progress, I'll try and give you hints. Just a little hint. Ah, wow. I wonder what that is. So nobody has still unlocked the door. Interesting. I mean, even me, I'm tired. Yeah? I can't hear what for the second contract, yeah? What are you getting? Undefined, not a valid player. You should be valid now. It gets its state from the first contract. So if you are valid on the first contract, then you should be valid on the second contract. Have you tried the first contract? Then that means you didn't register. And I'm not going to do any registration again. Please, you guys should try first. Even if you are like passing wrong info. So I would even know that you're trying. Yeah? No, don't show me anything. Just explain to me what you need. What do you need? Tell me what you need now. What do you need? I don't know. Everything is there. See, if you are solving the second contract, read the story. Read it. You got here. You're on the way. Read the story. The story is meant to be a guide. That's for challenge 2. Challenge 2 is the easiest. What's going on? Kai. $54 minutes more. And only 2 people have opened the door. Nobody has solved level A. Slow. Nice excuse. Nobody has solved level B. Nobody has solved level C. Nobody has solved level D. Yeah, the CTF is brutal actually. I know. That's the point. The hint, right? The hint, I can't give you a hint for level A, but I can give you a hint for the door that should allow anybody here to solve the door. So basically, if you check the previous transactions of the people that have solved it, you can see that in their transaction, they had 3, how would I put it in this case? 4 inputs. You guys know the crossword, right? You can easily get a word from the crossword. And that's all you need to input for X. Although in lowercase. So basically, this guy was able to solve it by inputting 111 as the unit 16 number. For the name, he used Ayodeji. I thought it was Yoruba. Though someone used Israel. Funny, right? For the secret missive, he used SEC underscore. God knows where he saw that. But that was what the second person used too. So that means it's somehow static. And finally, for X, he used beard. Right? You can see there, he solved, unlock the door with the key beard. That means all you just need to do is find another key from that crossword puzzle and use those 3 parameters with your key. And you're good to go. That's the simplest thing to do. Only door, yes. Even the second contract, although I have seen 2 people show progress with the second contract, they're almost done. So, but they have to follow the story. The second contract talks about a lot of bases. 91 bases, 64 bases. These things are encoding techniques. So I should say a lot of people solve it, they don't know. So they can easily solve level A. Level A is simple. Let me check the contract again. The answer is literally on Polygon scan. Like just copy what is there, paste. Everybody does copy and paste in exam, in project too. Now it's time to do it to get your money. So now level A in challenge 1 says Okay, level A. This is the hint about level A. Level A expects you to have a byte 32 value, and it checks for a lot of things and many other things, and finally a finality. Which check is failing? Oh, interesting. But your check is failing. The check should pass. It's simple. Level A is like also simple. You just need to like use pre-calculated values and you're good to go.
Is it failing for? Is it for Gary or is it for this?
It's that's me. It's a revert.
Is it for Gary or is it for this? Which one are you getting?
No revert error.
No revert error.
That means you are doing something very, very wrong. So, nothing again. You guys should open this door now. The funniest thing is that in level A, no check should give you a revert error without a reason, right? None. All the checks they have a revert reason. Oh, okay, 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 okay. So you have 49 minutes more. I don't care. The answer is already on chain. Just look at what other people did and do the same thing, except the key. For the second contract, here is the hint. The binary file you are given should be converted to UTF-8, right? And when you convert that binary code to UTF-8, you get a lot of strings that tells you the next thing to do. You get an incomplete paste bin link, which you are supposed to add something at front. That something is also encoded with something. And that something is in the story. Something base. I don't care. You want me to tell you everything now? Because we don't have time. Check your story. The story mentions your paste bin mentions 32 bases, right? And when you check the story again, it mentions something called 91 bases. I don't know. I might have been 90, guys. I thought this one would be out by now. I mean, it's really what that is out. What's 100? Thank God. I'm going on with $900. Thank you. Very happy.
You solved it. Which tool are you using? Adders. Remix. You're using Remix.
Just for you to know, we have pasted. We have this before. We have this one. So do whatever you want to do.
You said it's using Remix. It's not our fault.
No, painting.
When, how many hours ago? Who is facing issue with contract deployment?
I sent Martin to 40 people.
You will return our match.
You have to return it back. Now you have to do something. Oh, I'm not telling everybody.
For the contract, to those that have gotten the key, they say they don't know what to do with the key. And they've gotten the key, but they don't know how to interact with the smart contract.
They have gotten the key. If you have gotten the key for contract two, I provided an interface that is in that file. All you just have to do is interact with the contract with that interface. And you are good to go.
Your contract is not compiling, no. The contract I saw there is not compiling, no. It was throwing error that time now. It's an external view function. Even if you have remix.
Function there called submit key that accepts the key that you assume you got. What's the point? The function is, have you seen how they pay me? It's there now.
Look at people coming behind you to get the key from you. Okay. People that knows how to use interface will use your key to get the money. And you won't get a dime. What's going on here? I miss you guys. Error overload. Error. I don't know. I don't know. If pause is not working, maybe somebody have used it before. You can, okay.
Entrance or something. So yes. Then how you yeah.
No, it's showing correct. Which one is Windows?
I just give her like 10 keys or something. You know what?
They want to collect the key from you and use it to win the money. For the second contract. Look at them. You want to show them the key. Okay.
That's 273,000 naira. Easy. It's there, like waiting for you to just fix it up. As soon as you can check.
Yeah, actually. They are all senior devs. Well, me. I cannot teach you smart contracts in class. Just maybe why you're having that issue. Maybe you should ask God why you're having that issue. It's telling you that you cannot deploy it because it's you should mark it abstract. Check God why.
That give you the right amount of solve level B, you need to perform re-entrance at a particular number of times. To solve level C, you need to do MSD.sender and to solve level B, you also need to do MSD.sender and your contract needs to return a video story. That's
Wait, giving all the keys and nobody has solved.
That's like everything. That's it.
Does that mean that even if you provided the keys this morning, nobody will get it or what?
That was what I was telling them.
where are you facing to? You are facing pending issue there too. saying the PSB link is wrong, blah blah blah. Now somebody has cracked it. He said, "Oh, sorry." The second challenge, the second contract is gone. We have zero. You can check Polygon scan for confirmation. Maybe who cracked it?
Who is Mike Francis?
Mike Francis, cyber security guy. You cracked it, my guy. Congratulations. Awesome. They were saying that the PSB link is wrong. They said we don't know what we are doing in the question. It's wrong. Everything is wrong. But thank God.
It's actually simple. So basically, when you check the GitHub, you actually get for challenge 2.md, you get a lot of binary digits, right? And when you convert those binary digits to string or UTF-8 encoded characters, you get a story. The story gives you a paste bin link, incomplete paste bin link, right? And it tells you what you are supposed to do to get the remaining. The second one is encoded with base 64. So all you have to do is copy it, the code with base 64, get the link, then go to the paste bin link. When you access the paste bin link, you get rubbish, right? You get rubbish, but it's not rubbish. According to the story, it mentions 91 bases. So base 91 encoding. You decode that with base 91, you get a GitHub gist, right? And that GitHub gist contains two. The first one is encoded with ROT13. The second one is encoded with ROT47. When you decode both of them, you get byte 16, byte 16. Bring both of them together, you get byte 32. That is your slot. Then you call the contract with byte 32 to get what is in that slot. It returns a struct, an address, and a key. Then you just take the key and input it, and you get your money. It's the simplest challenge I've ever done, actually.
It is simple to you. You can see that the process is done. Let me go and get the bad guy.
There's still $600 in the first contract that nobody wants to take. I don't know why. So,
Fudge what? It's good. It's giving error. Okay. You guys are using scripts to deploy. We don't use Fudge code to.
So look at it.
I cannot tell you. Your file is not even compiling. Your file is not even. And you do Fudge update and Fudge install. From cohort 7 and cohort 8, Mike Francis not so. And somebody from cohort 7 got the first one. Expecting. No, it's not Monex. No, it's Monex. It's Monex. Joseph, then Mike Francis.
I mean, it's like the easiest city I've ever seen. I don't know why you guys built.
Your foundry is not building. Fudge install. Do Fudge updates.
14 minutes. Oh.
So if you do not try what it has updated, do Fudge.
There's still $600 for Christ's sake.
Do foundry. Joseph, are you using the foundry? Are you able to view? Okay, you view. 13 minutes. Just foundry up your update your foundry, then try to build. Where people should shut the door now and compete with level A. Plenty people that are competing with see. My fancy. Our bad guy. Our latest bad guy. Has he updated? Are you still having issue? Is it building now? It's working now, Abby. So it's a foundry that is outdated. I like it. So, just let me. Why are you looking at me like this? I think very bad. I don't know why you guys start. That's why it's this contract is not declared. So yeah, let me attend to it first. He said it. Have you called it? Have you been able to call it? Your function will pass, but it doesn't mean that you're put it up. What are you guys getting?
Same. So we are trying it again, though, but this was the error it got before that contract was not.
Why is it not deploying? Maybe network or something. That's not foundry. Like they are returning an error. The error they are getting from Metascan to you back. But your first bill is your first is provided now. So the 10. So we have approximately. How did you explain that? They already found it. She was using outdated foundry to run the template. They still haven't solved level B now. Level B is where the money is. Level C. Okay. Okay, there's money in level C too. I think there's money in level. Check your wallet address. There's money in level C. Send it everywhere. Somebody is getting the higher percentage of the money. That's what you did. That's what you did. That's what you did. So, for everybody here, I'm going to be giving you the answer to the door. So, like, we have 9 minutes more, it's going to be a rush. So, you can either solve it or to the door. Yes. So, here's an answer. For the not in 29, but game, it should
For the secret missive. Oh, okay. 2929 Ayodeji. Super simple. And then a key. You can get any of those keys from the crossword. The key. Just check the crossword. You can get those keys there. They are simple. It's a crossword puzzle now. Like, oh, you want me to give you the keys too? Anyone? I think I have some of them here. So we have merit, we have speed, we have apple, we have Babel. No, let them continue opening it. It's a rush, actually. There is chair, there's elude. Sorry, etude. There's etude. There is clash, there is apron, there is track, there is bongo, there is alike, there is crane, there is gloss, there's gamer, there's Q, there's actor. Pick your poison. Eh, now everybody's on look, 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 look. Which next one? You're asking me? I said this is for. So you have 4 minutes more. In fact, 7 minutes. Kilo tuku. Kilo ku. More keys incoming. There is merit. There is speed. There is valor. There is sure. There is cycle. There is apple. There is Babel. So I want to see people solving level A now. Level A is the simplest level to solve. Just solve it and get your $100. It's up.
Hello. Can we please have quiet for 5 minutes? Thank you. Hello. Can we please have quiet for 5 minutes? Thank you. Hello. Can we please have quiet for 5 minutes? Thank you. Hello. Can we please have quiet for 5 minutes? Thank you.
Hello, everybody. Can you hear me? Can you see me? Hello, everybody. Can you hear me? Can you see me? I can't see anyone, and so I don't know. I guess I should I start presenting? I just see myself on the screen, and so I'm having a hard time getting my orientation. Oh, there we go. Now I can see everyone. Hello, everyone. Oh, no, I can't. Hey, everyone.
Hello, can you hear us? You can't hear us. No, you can hear us. Hello, can you hear us, please? Hello, Jesse. Yeah, I can hear us. Okay, okay, okay. Okay, can you hear us? Hello, can you hear us, please? Hello, Jesse. Yeah, I can hear us. Okay, okay, okay.
There we go. Now I'm on.
Hello, can you hear us, please?
Yes, I can
Hello, Jesse.
hear you. Yes. Hello, everybody.
Yeah, I can hear us. Okay, okay, okay.
There we go. Now I'm on.
Hello, can you hear us, please?
Yes, I can
Hello, JC.
hear you. Yes. Hello, everybody.
Yeah, I can hear.
There we go. Now I'm on.
Hello, can you hear us, please?
Yes, I can
Hello, JC.
hear you. Yes. Hello, everybody. Okay, I guess I'm gonna get started. I think I'm on the screen. I think y'all can hear me. So I'm gonna just dive in. If I hear otherwise, I will stop. There we go. So Now I'm on.
Hello.
I'm also getting a little bit of echo, so it may be a little bit of a challenge, but I'm trying my best. Hey, everybody. I'm Jesse. I'm the creator of Base. Okay, I guess I'm gonna get started. And I think I'm on the screen. I think y'all can hear me. So I'm gonna just dive in. If I hear otherwise, I will stop. There we go. So now I'm on. I'm also getting a little bit of echo, so it may be a little bit of a challenge. But okay, I fixed the echo by just turning off the sound. I'm Jesse. So I've muted the window. Okay, So I I'm guess just I'm gonna gonna dive get in, started. And we can figure out if we want to do questions in a little bit. But let me just get started by presenting. So I'm gonna put my screen up. Let me just start at the beginning. Presenter view. Let's see if we can put that up on the screen. Can we put the slides up on the screen? There we go. Nice. Awesome. Slides are up. Awesome. Hey, everyone. I'm Jesse. Super excited to be here and going to be talking about why on-chain is the next online and what Base is doing to make that happen. So as a reminder, I'm Jesse. I'm the creator of Base. If you haven't heard, Base is an Ethereum layer 2. If you want to get in touch with me, you can scan this QR code right here. That'll let you message me on-chain with Coinbase Wallet or Lens or Converse. You can use any apps to do that. And so that's a good way to get in touch with me. And I'm here to talk about the kind of message that on-chain is the next online. And I don't know if folks here have all heard that word on-chain. And so maybe just want to quickly define that. We really think about the internet happening in 3 eras. There was the kind of pre-internet era, which we call offline. And that was when we were all kind of contained to where we lived. There was no real way to reach the rest of the world. And information and money were managed by kind of central gatekeepers, right? If you wanted to learn something, you went to the TV or the news or the radio or your local source of information. If you wanted to create something, you had to go through publishers and producers and people who basically controlled who could have a voice. And then the internet happened, and we call this the online era. Started in the 2000s and is continuing through today. And for the first time, everyone everywhere could have a voice. And this is what enabled Twitter and Facebook and Google and kind of gave everyone a platform. And it connected the world in a really powerful way. But the problem was, even though everyone could have a voice, that voice was still controlled by large centralized companies. And it was contained to just having a voice. There were still a lot of things that many people couldn't do with money or value. And right now, we believe we're on the verge of the next era of the internet, which we call the on-chain era. And we think that the powerful thing about the on-chain era is that for the first time, both information and money are fully permissionless and open. And what that means is it means that anyone anywhere, no matter where you're born, no matter where you live, can build applications that use information, that use money, and those applications can be used by anyone anywhere. And we're seeing that this new version of the internet is really starting to take off. So this is the number of users. You can see that it's growing very quickly up and to the right. This is the number of developers. I think a lot of people in this room are developers. That's also also been growing very quickly up and to the right. And I think excitingly, we're also seeing a lot of use cases emerge. And these are real things that people are doing on chain, whether it's advocacy or social media or restaurants or gaming or education. You know, increasingly there's real things that everyday people are doing on this new platform. And all of this is leading to more and more transactions happening on chain. The blue line is the number of Ethereum transactions. And you can see that's been pretty flat. That's because Ethereum's been running at capacity for the last while. The red line is the number of layer 2 transactions, which are kind of scaling solutions on top of Ethereum. You can see that that's been growing up into the right. And we expect that that's just going to keep growing because there's going to be more and more things to do on chain. And the really exciting thing about this is that it's still very, very early. So y'all sitting in this room are part of the 0.1% of the world that's, you know, interacting and learning about this new platform. There's 8 billion people in the world. There's less than 10 million people on chain. And I think we believe that our vision, you know, when we're thinking about what is Base, is that we want to bring 1 million developers and 1 billion users on chain. So that's kind of our goal. We see this chart where there's a really small number of people on chain today, and we want to say, okay, let's change that. And let's bring everyone on chain. And let's do that by creating a world-class on-chain developer platform in the form of an Ethereum layer 2. And so that's what Base is. Base is an Ethereum layer 2 built to scale the crypto economy or the on-chain economy. It is built for security and ease of use and low cost. It's incubated inside of Coinbase. It's secure. It's really cheap. We built it in a fully open source way. And it has a thriving open ecosystem where anyone can build. And we've done that in collaboration with Optimism and the OP stack. We've kind of built it in this way because we believe that that's a critical investment for ensuring that Base and other chains remains open, remains available and accessible to everyone no matter where you are. And we brought Base live in early August. We launched it publicly on August 9th. And since we launched it, Base is the fastest layer 2 to reach 100,000 users. It's already the 3rd largest layer 2 in terms of the amount of value locked in it. And we're seeing an incredible number of applications that are being built on Base that are really pushing the limits of what's possible on chain. So today there's already more than 100 dApps live that are really powering the next generation of on-chain use cases, from gaming to finance to media to DAOs to social to wallets to bridges. Really kind of everything is coming to Base to help bring the next billion users on chain. And I think one of the things that's gotten me really excited is through our collaboration with Web3 Bridge, through our collaboration with businesses like Onboard, we're also seeing a ton of builders building on Base in Africa. The 2 ones to shout out here is Onboard, which is started by Yele Badasami, who's awesome and we love. They're making money borderless with their decentralized peer-to-peer exchange. You can use Onboard to get into crypto, get out your first wallet. Web3 Bridge is bringing a classroom on chain with classroom management system that they've been building on Base early. And has been like a key part of the curriculum that we are helping develop and support in order to bring more developers from the continent on chain. And one of the reasons that this I think is really important to me personally is I've spent a lot of time on the continent in Nairobi in particular. Both of my brothers live there. They help run a business called Apollo Agriculture. I don't know if folks have heard of that, but they support local farmers. And so that's given me a chance to really be on the ground and see, whoa, there's such a huge opportunity for us to create better economic systems and give people better tools to build businesses, to support their families and to live better lives. And so Base is supporting builders in Kenya and Nigeria and all across the continent a huge priority for the years ahead, because at the end of the day, that's the thing that we think is going to lead to the best outcome for everyone everywhere. And I think my message to all of y'all, just to close it out, is that we think that over the next many years, this is what that chart is going to look like. We're going to go from having a pretty good growth spurt right now to it just continuing to go up and to the right. And so that's why on-chain is the next online. And I think the message for all of y'all is that it's time to build. And so thank you for having me here. I'm really grateful to have the time and space, and excited to keep building with all of y'all in the years ahead. If you want to get started building on Base and you've already deployed an app, you can apply for the Genesis Builder NFT. This is just a recognition that you were here early. You can do that at builder.base.org. If you want to get help or support building on Base, you can connect with us in Discord at base.org/discord, and on Twitter at buildonbase. And we're here to support you in building in whatever way we possibly can. So that's the end of the presentation. I don't know if we're going to be able to do it, but I'm happy to open it up for questions and see if folks have any things they want to ask about Base, about on-chain, about where the world is going over the next 10 years.
About what's going to happen on chains maybe for the next 10 years.
Sorry, can you hear me?
Yeah, I can hear you.
Hello, can you hear me?
About what's
Yes,
going to
I
happen
can.
on chains maybe for the next 10 years.
I can hear you, but there is like a 30 to 40 second delay. So
sorry,
you guys
can you
should
hear
just
me?
ask questions. Yeah, and I can hear you. Answer the questions.
Yeah, so I actually wanted to ask about the base bridge. Hello, can you hear me?
About what's
Yes,
going to
I
happen
can.
on chains maybe for the next 10 years.
I can hear you, but there is like a 30 to 40 second delay. So you
sorry, can
guys
you
should
hear
just
me?
ask questions. Yeah, and I can
will
hear you.
answer
The questions.
So I actually wanted to ask about the base bridge. Hello, can you hear me?
About what's
Yes,
going to
I
happen on
can.
chains maybe for the next 10 years.
I can hear you, but there is like a 30 to 40 second delay. So
sorry,
you
can
guys
you
should
hear
just
me?
ask questions. Yeah, and I can hear you. Answer the questions.
So I actually wanted to ask about the base bridge. Hello, can you hear me?
About what's going
Yes,
to happen.
Wanted to oh sorry, I wanted to ask about the base bridge on Ethereum minutes and how it works, how it connects assets from Ethereum minutes to the base minutes in this case. I mean, you just have deposit on Ethereum minute and then you get those assets credited to your EOA on base. So that's just it. I wanted to
Yeah,
ask
so
about the base bridge on Ethereum minutes and how it works.
the question I'm
how
hearing is, how does the base bridge work? The TLDR of how the base bridge works is that when there's basically smart contracts on Ethereum layer 1, and they're connected to the node software that runs Base on layer 2. And so when you deposit into the bridge, whether it's a Ethereum or it's an ERC20 token, those assets get found in the base bridge. The question I'm hearing is, how does the base bridge work? The TLDR of how the base bridge works is that when there's basically smart contracts on the Ethereum protocol, and a core part of the security guarantee. in the way that Base is built, that you're always going to be able to deposit and then you're always going to be able to withdraw permissionlessly. And we've built that bridge in collaboration with Optimism. And we are working to continue increasing the security of that bridge, the monitoring, but overall it's a really kind of secure way of moving assets between it. And we recommend that for native assets like Ethereum and ERC20s, folks use that bridge rather than using a third-party bridge like Wormhole or Axelar. Let me know if there are any other questions.
Identity-based system like ENS, or is it connected to a subdomain to Ethereum? Like ENS. ENS. Or is it attached as a subdomain to?
Got it. So the question is, do we have an identity-based identity system like ENS on Base, or is it attached to a subdomain to ENS, like ENS? We don't currently have a canonical official identity system on Base. There's people who've been kind of experimenting with and building different .base domain names. Got it. So the question is, do we have an identity-based identity system like ENS on Base, or is it attached to a subdomain? My intuition is that we will likely work closely with ENS to extend ENS and bring it to layer 2. And so, for instance, we have different .base domain names. Got it. So the question is, do we have an identity-based? So you could have Jesse.base study. But that's not something we've done currently. On the Coinbase side, there's .cv.id, which is the kind of Coinbase ENS integration. And I expect that we'll continue expanding that as well. And so I think generally our thesis is that because Base is an Ethereum layer 2, it makes sense to extend and build on the Ethereum name system rather than creating a new name system. I think that's the last question. And I'm gonna drop in a minute, but I just want to say thank you again for having me. It was really an honor to be here. I know there were some technical difficulties, but I think we worked through them. We got a couple questions in, we got the presentation in. I'm gonna be coming to the continent sometime in next year. I'd love to meet people here and connect further. In the meantime, we're going to continue supporting builders kind of in Lagos and around continent. We are excited to keep being here and helping bring the next billion people on chain. So thank you so much for having me. And I'm excited to build together with y'all. See everyone.
Uh, Thank you so much.